On March 26, 2024, about 1:29 a.m. Eastern Standard Time, the container ship Dali was transiting out of Baltimore Harbor in Baltimore, Maryland, when it experienced losses of electrical power, propulsion, and steering, and struck Pier 17, the southern pier that supported the central span of the FrancisScottKeyBridge. A substantial portion of the bridge subsequently collapsed into the river, and portions of the pier, deck, and truss spans collapsed onto the vessel's bow and forwardmost container bays. Tragically, 6 workers who were on the bridge died as a result of the collapse. A 7th worker survived but suffered serious injuries. An inspector escaped without physical injuries, and one of the 23 crew members aboard the Dali sustained minor injuries. On behalf of the entire agency, I want to extend our deepest sympathies to those who lost loved ones in this terrible, terrible tragedy, as well, of course, of the survivors who I hope are on the mend. I was the board member on scene for this accident, and I met with the families, and I boarded the Dali several times and saw the devastation up close. I can only imagine what the families and survivors have gone through over the last 20 or so months. I also imagine that this has been difficult for those who witnessed the devastation, the senior pilot who called for help as the vessel approached the bridge, the pilot dispatcher who notified the Maryland Transportation Authority, the MDTA police who were on the bridge at the time and who within seconds closed the bridge to traffic, saving countless lives, and the crew aboard the Dali, many of whom are still in the United States. For those in the room or in the family briefing room, Elias Quintanas from our Transportation Disaster Assistance Division is here and will be here throughout the course of the board meeting to provide support to anyone who may need it. Elias and I think that's Max back there, Max Green, if you could just raise your hand. If anyone needs support, please come see them. They'll be at the back of the room. The fact is, none of us should be here today. This tragedy should have never occurred. Lives should have never been lost. As with all accidents that we investigate, this was preventable. Throughout this meeting, you're going to hear exactly how. I'm not going to get ahead of the staff presentations, but what I will do is express our deep, deep appreciation, first, to those who responded to or assisted with the response to this accident. And it is a long list, but they deserve our recognition, so thank you for your patience as I go through the list. The American Red Cross, Baltimore City, Baltimore County, the Cybersecurity and Infrastructure Security Agency, the Environmental Protection Agency, the Federal Bureau of Investigation, the Maryland Air National Guard, the Maryland Department of Emergency Management, the Maryland Department of the Environment, the Maryland Department of Transportation, the Maryland Natural Resources Police, the Maryland Port Administration, the Maryland State Police, Maryland Transportation Authority, the National Oceanic and Atmospheric Administration, the U.S. Army Corps of Engineers, the U.S. Coast Guard, including the Atlantic Strike Team, and the Salvage Engineering Response Team, U.S. Customs and Border Protection, the U.S. Department of Transportation, including the Federal Highway Administration and the Pipeline and Hazardous Materials Safety Administration, the U.S. Navy Supervisor of Salvage and Diving, and Whit O'Brien's, who was Synergy's Emergency Response Company. I also want to thank the Salvers, Resolve Marine, and Don John Marine, And I want to thank our colleagues in the Office of Marine Safety, the Office of Highway Safety, the Office of Research and Engineering and Safety Recommendations and Communications for their meticulous work. This was a complex, multimodal investigation, extremely complex, with tremendous challenges. I also want to recognize two people in our audience today who are former but still our colleagues. Rob Hall, who was our Director of Rail, Pipelines, and Hazardous Materials, and Paul Stansel, who was our head of the Hazmat Division, and Paul was on scene for this, not just for Hazmat, but for the pipeline that was running through the channel as well. So thank you both for being here. Finally, I want to thank staff throughout the entire agency for their hard work and dedication to our mission, especially during the government shutdown. Know this, every single one of you is essential, absolutely essential to our safety mission. I hope you know that you are highly valued, not just by this agency, but by all the board members. So let's now turn to today's meeting. Our Deputy Managing Director for Investigations, Brian Curtis, will introduce the NTSB team participating in today's meeting, and then we'll go into staff presentations. Once staff presentations are done, the board will deliberate. We will ask questions about focused safety issues that we want to raise and highlight in the board meeting. This is the first time the board has gotten together to deliberate the findings in this investigation. But there's some issues that we want to really highlight stemming from the investigation. Then we'll consider a set of findings, the probable cause or causes, and a set of recommendations that are aimed at improving safety and making sure that this never, ever happens again. So with that, good morning, Mr. Curtis.
Thank you, Chair Hamady, and good morning to the board. I'll now introduce staff for today's meeting. Unless otherwise noted, staff from the Office of Marine Safety. In the front row to my right, Dr. Chris Poland, Acting Director for the Office of Highway Safety. Eric Stolzenberg, Director for the Office of Marine Safety. Captain Marcel Muse, Investigator in charge for this accident. Bart Barnum, Engineering. Captain Bridget Quinn, Nautical Operations. Second row behind me, left to right, Tom McMurray, NTSB's General Counsel. Jennifer Adler, Director for the Office of Safety Recommendations and Communications. Adrian Lamb, Materials from the Office of Research and Engineering. Todd Ginalone, Engineering. Scott Parent, Bridge Structures from the Office of Highway Safety. And the third row, left to right, and Sean Payne at the end of the second row, Recorders, Office of Research and Engineering. Third row, Daniel McClay, Audio Visuals for this meeting. Elizabeth Christopher, Report Writer. Brandy Baldwin, PE, Chief of the Safety Recommendations of the Office of Safety Recommendations and Communications. Liam LaRue, Chief for Marine Investigations. Michael Badinsky, Acting Director for the Office of Research and Engineering. Dan Walsh, PE, Bridge Structures from the Office of Highway Safety. Additional staff present to respond to board's questions, we have Matthew Yandrick, Recorders from the Office of Research and Engineering. Dr. Jana Price, Safety Research from the Office of Research and Engineering. Dr. Carl Schultheis, Vehicle Performance from the Office of Research and Engineering. And Rachel Gunnaratnam, Hazardous Materials from the Office of Railroad, Pipeline, and Hazardous Materials Investigations. And Dr. Dewan Civilian, Human Performance from the Office of Aviation Safety. The presentations will begin with an investigation overview by the investigator in charge, Marcel Muse. Mr. Muse.
Thank you, Mr. Curtis. Good morning, Chairman Hamady and members of the board. This morning, staff will present our investigation into the contact of the container ship Dali with the FrancisScottKeyBridge, which occurred on March 26, 2024. In addition to those who are participating in today's meeting, I'd like to acknowledge the staff noted here for their support and assistance during the investigation and report development. I'd also like to acknowledge the staff noted here who facilitated this board meeting. Parties to the investigation are listed here, and we thank them for their assistance throughout the investigation. Substantially interested states are listed here. We also thank them for their assistance. The Dali was a 984-foot-long Neo-Panamax container ship built in 2015 in Ulsan, South Korea. The ship operated in the container liner trade between Asia and the U.S. East Coast. The Singapore flag ship was owned by Grace Ocean, operated by Synergy Marine Group, and was classed by Nippon Kaiji Kyokai, also known as Class NK. The Francis Scott Key Bridge carried Maryland Route 695 over the Patapsco River from Baltimore to Dundalk. The bridge was owned and operated by the Maryland Transportation Authority and opened to traffic on March 23, 1977. On the morning of March 26th, a crew of 7 highway workers and 1 inspector were working on the bridge, repairing potholes. The Dali arrived in Baltimore at the Seagirt Marine Terminal, shown here, on the north side of the harbor on the morning of March 23rd. Cargo was completed on the evening of March 25th. The crew completed pre-departure checks before 2 pilots from the Association of Maryland Pilots boarded the ship shortly after midnight. The ship was assisted off the pier by 2 harbor assist tugs at 036. This chart shows the Fort McHenry Channel and Dali's outbound passage towards the bridge. The channel is 700 feet wide with a base course of 140. The channel has a projected depth of 50 feet, and Dali's underkill clearance was about 10 feet. The Curtis Bay Channel intersects the Fort McHenry Channel about a half a mile north of the Key Bridge. Environmental conditions were favorable, and the accident occurred in darkness. This graphic displays the ship's power management system. Glowing yellow parts represent online machinery or live electrical circuits. The Dali was propelled by a single, slow-speed, 57,000 horsepower diesel engine, which was directly connected to a propeller. A vessel's rudder was moved by rams and up to 3 steering pumps. The ship's electrical power was supplied by 4 diesel generators. The diesel generators were connected to a high-voltage main electrical bus that directly powered certain shipboard equipment, including the main engine lubricating pumps, the bow thruster, and refrigerated containers. The Dali had a low-voltage bus, which was powered from the high-voltage bus through a pair of redundant step-down transformers, depicted here as TR1 and TR2. The low-voltage bus supplied electrical power to Dali's remaining equipment and services, including the steering gear, main engine cooling water pumps, fuel oil pumps, and vessel lighting. The vessel was also equipped with an emergency diesel generator, which is designed to start automatically following a blackout and supply power to the emergency bus and some critical systems. The components and circuits shown here that are glowing yellow show the configuration of the vessel as it got underway prior to the accident. Generators 3 and 4 were running and powering the vessel. The bow thruster was on, but was not being operated. The low voltage power was being supplied from step-down transformer number 1. About 0108, the ship entered the Fort McHenry Channel. The senior pilot let the assist tugs go, and as the ship lined up in the channel, he turned the con over to the pilot in training. Speed was then increased to slow ahead. At 0125, as the ship approached the intersection of the Curtis Bay Channel with the Fort McHenry Channel, breaker HR1 unexpectedly opened. The ship experienced a low voltage blackout. As a result, the vessel lost steering the ability to operate the bow thruster, and most of the vessel's lighting and equipment essential for operations. 8 seconds later, the cooling water pumps essential for the main engine to operate shut off due to the low voltage blackout. Loss of the cooling water pressure triggered an automatic main engine shutdown, causing the vessel's propeller to come to a stop. The main engine, as well as the bow thruster, remained off throughout the remainder of the casualty. At 1:25 and 58 seconds, almost a minute after breaker HR1 unexpectedly opened, causing the blackout, the vessel's engineering crew manually closed breaker HR1 and LR1, restoring low voltage power. Much of the equipment that had shut down with the initial loss of low voltage power began to automatically restart, including most of the vessel's lighting and steering gear pumps. The electric pump supplying the fuel to generators 3 and 4 was not capable of restarting automatically following the restoration of power and remained off. To restart this pump, a crew member had to do so manually from a local station. Generators 3 and 4 remained running by consuming the remaining fuel in the supply line. The ship was closing with the bridge at 8.6 knots. The vessel developed a starboard rate of turn of 4.5 degrees per minute, and the senior pilot gave a port 20-degree rudder command. He also called his dispatcher by cell phone and requested the bridge be closed to vehicle traffic. He then called for tug assist by radio. Sensing the loss of power to the emergency bus, the vessel's emergency diesel generator automatically started and powered the emergency bus at 1:26 and 10 seconds. Emergency lighting around the vessel came back on. As the fuel pumps for generator 3 and 4 had still not been manually restarted, what fuel remained in the supply line was insufficient to keep the 2 generators running, and the generators began to stall. Sensing the underperformance of generators 3 and 4, the vessel's automated power management system automatically started standby generator number 2. 66 seconds after the low voltage power was initially restored, and before generator 2 could come up to speed and connect to the high voltage bus, the power management system disconnected generators 3 and 4 due to their inability to maintain a rated speed to produce sufficient power. This resulted in a second blackout. This time, both the high voltage and the low voltage buses blacked out. The emergency generator continued operating and powered the emergency bus through the second blackout, which supplied power to some of the vessel's lights, navigation equipment, and a single steering pump. 3 seconds later, at 1:27 and 7 seconds, generator 2 reached a rated speed and the power management system automatically connected it, repowering the high voltage bus. One diesel generator alone could run all of Dali's power needs at this time. Generators 3 and 4 remained running in a degraded state and were unavailable to be connected. On the navigation bridge, the pilot ordered the port anchor let go and increased the rudder command to hard port, or 35 degrees. At 1:27 and 36 seconds, the vessel's engineering crew manually closed breakers HR2 and LR2, restoring power to the low voltage bus, this time through step-down transformer number 2. Again, similar to the recovery from the initial underway loss of power, much of the equipment that had shut down due to the second loss of power began to automatically restart, including most of the vessel's lighting and 2 additional steering pumps. Unlike the fuel pump for generators 3 and 4, which required a manual restart, generator 2's fuel pump was set to automatically restart following the restoration of power. The ship was now on a heading of 155, 1,200 feet from the bridge, and closing at 7.5 knots. The rudder was hard over, which had little effect without any propulsion. The right southbound lane of the bridge had previously been closed, and MDTA officers were stationed on either end of the bridge to assist with traffic. About this time, they were told of the emergency and instructed to close both ends of the bridge to all traffic. About a minute before the contact, the crew manually restarted the fuel supply pumps for generators 3 and 4. And the generators returned to a normal speed. Displayed is the configuration of the system when the ship contacted the bridge at 1:29 and 9 seconds. The Dali's bow contacted Pier 17 at 6.4 knots. the A-frame columns collapsed. This infrared camera looking north captured span 17 and the main span 18, collapsing. Spans 19, 20, 22, and 21 followed. The last southbound vehicle cleared span 17, 31 seconds before it collapsed. Shown here is the last vehicle to safely cross the bridge in the left lane. Dali can be seen on the right, as indicated by the yellow circle, seconds before the second blackout. Although vehicle through traffic was stopped, the 7 highway workers fell in their vehicles into the water. The inspector, who was out of his vehicle and walking the length of the bridge, ran to safety on the north side as the bridge collapsed behind him. One crew member on board Dali was injured by falling debris. An MDTA police boat rescued one seriously injured highway worker who had escaped from his truck. The remaining 6 fatally injured workers were recovered over the next several days. All were found in their vehicles. Shown here is an extract from the dash cam of the last southbound vehicle to safely cross the bridge. Traffic can be seen stopped by MDTA officers on the opposite side by the time this truck reached them. Staff believes the following items were not factors in this accident: the environment or waterway conditions, the vessel's complement and mariner credentialing, the impairment of the Dali crew or pilots due to alcohol or other tested for drugs, fuel quality or the switchover of fuels, the ship's ability to get underway after an import blackout, and bridge construction with non-redundant steel tension members. Staff will discuss the following safety issues: the improper placement of wire labeling banding on terminal connection wires, the lack of specific guidance for inspecting terminal connections, the configuration of machinery and electrical systems needed to prevent the loss of propulsion, the lack of effective means of emergency communications to warn motorists and notify highway workers, inadequate standards for marine safety management systems, the inadequate standards for the specifications and performance of voyage data recorders, the increasing vessel sizes and traffic density in U.S. ports, and the vulnerability of bridges over navigable waterways to strikes by large ocean-going vessels. This concludes my presentation. Engineering Group's co-chair, Mr. Giannelloni, will now discuss engineering aspects of this accident.
Thank you, Mr. Muse. In this presentation, Ms. Lamb, Mr. Barnum, and myself will discuss the engineering-related findings of this accident, including the causes of the 2 underway vessel power losses. As part of the post-accident investigation, the engineering group focused efforts on determining why HR1 unexpectedly opened, causing the initial underway low-voltage blackout. After several weeks of electrical examinations and troubleshooting, a loose signal wire associated with breaker HR1 was discovered. This wire, referred in this presentation and in the draft report as wire 1, was found to be loosely connected to an electrical connector identified as terminal block 381, creating an intermittent electrical connection. We will now play a short animation that discusses the control wiring and terminal blocks aboard the Dali.
The Dali electrical system distributes power and control signals throughout the vessel.
Sorry, can we turn up the volume?
Contain hundreds of terminal blocks
Or
that
start
organize
again?
Thousands of wires.
With a higher volume?
The wires on the Dali were terminated with metal sleeves called ferrules that allowed for easier assembly into the terminal blocks. Each wire was identified with a The Dali electrical system distributes power and control signals throughout the vessel. The control circuits contain hundreds of terminal blocks that organize thousands of wires. The wires on the Dali were terminated with metal sleeves called ferrules that allowed for easier assembly into the terminal blocks. Each wire was identified with a labeling band. This image shows several terminal blocks on the Dali with wires connected. To assemble a wire into a terminal block, a tool inserted into a side port opens a spring clamp, which allows the wire's ferrule to slide into place. Removing the tool closes the spring clamp, securing the ferrule firmly against the terminal block's internal conductor bar. Labeling bands identify wires and are typically positioned on the wire insulation. However, many labeling bands on the Dali wires were placed partially on the ferrules, which increased the ferrule's overall circumference. As a result, during vessel construction, some of the ferrules could not be fully inserted in the terminal blocks, including the ferrule on wire 1 from terminal block 381. On that wire, the labeling band prevented full insertion of the ferrule, so the spring clamp gripped only the ferrule's tip, resulting in an inadequate connection. Due to this unstable connection, over time, the ferrule on wire 1 slipped out of the spring clamp to rest atop the spring clamp face, resulting in a precarious electrical connection. When a gap occurred between the ferrule and the spring clamp face, the electrical circuit was interrupted, leading to a blackout on the Dali. The Dali electrical
Staff found that the initial March 26 low-voltage blackout was caused by wire 1 electrically disconnecting from terminal block 381 within the HV switchboard, which resulted in high-voltage breaker HR1 opening, interrupting power to step-down transformer TR1 and the LV bus. Further, staff believes that the position of the wire label banding on the ferrule of terminal block 381's wire 1 prevented wire 1 from being fully inserted into the terminal block spring clamp gate, causing an inadequate connection and leaving wire 1 loose and vulnerable to becoming electrically disconnected. Staff proposes one recommendation to HD Hyundai Heavy Industries, and one recommendation to Wago Corporation, and one recommendation to Class NK. Synergy, the vessel operator, required the crew to complete high-voltage switchboard inspections periodically. However, the work instructions for these inspections did not provide practical guidance for inspecting the individual signal wires and terminal connections within the switchboard, including wire 1. Wire 1 was one of thousands of signal wires within the switchboard and throughout the vessel. Checking thousands of wire connections by hand would be extremely labor-intensive and would also prove operationally challenging, as the vessel's electrical systems would often have to be turned off while crew members inspected the individual connections. Furthermore, continued manual manipulation of the small and delicate signal wiring and terminal connections could introduce additional risk due to human error and could lead to premature failure over time. Infrared thermal imaging, or thermography, is an inspection and maintenance technique that allows inspectors to identify possible points of failure that may not be visible to the human eye without touching the electrical components being examined. It was not being used aboard the Dali prior to the accident. Thermography uses an infrared camera to observe the surface temperature of a wire. It can be used to help identify inadequate termination of conductors, such as wire 1 in a terminal block 381, as well as overloaded circuits by detecting increased local temperatures in electrical systems. It can also help detect faults early before they come to serious problems. Infrared thermal imaging is used widely for inspections in the maritime shipping industry and is a condition-based monitoring technique approved by various classification societies. The National Fire Protection Association, as well as marine insurance groups, recommend thermal imaging surveys of electrical systems be conducted periodically. Further, Wago Corporation, the manufacturer of Terminal Block 381, uses thermal imaging during their production and quality assurance processes to ensure that its components are not defective. Staff believes if infrared thermal imaging had been used to inspect wire connections within the HV switchboard before the accident as part of the Dali's preventative maintenance program, the loose signal wire may have been identified. Staff proposes one recommendation to Class NK and one recommendation to Synergy Marine Group. Mr. Barnum will now continue.
Thank you, Mr. Ginalone. Modern ocean-going vessels are complex pieces of engineering. They are essentially floating cities designed to spend years continuously operating in challenging environments, transporting goods and people around the world. Like most modern equipment, vessels are dependent on electricity to maintain their functionality. Therefore, an unexpected blackout has broad implications for the vessel. Although blackout events are rare, they do occur for various reasons. Given the complexity of a vessel's machinery, recovery from an unexpected blackout is factored into vessel design. However, full machinery recovering can still be complicated and time-consuming. When the Dali initially lost low-voltage power while underway, most of the vessel's lighting and equipment essential for operation were also lost. The vessel's alarm monitoring system did not provide the engineering crew members with any warnings or initiating alarms that alerted them of the impending blackout. Despite this sudden blackout, which resulted in numerous alarms sounding immediately, simultaneously, and continuously, the crew members in the engine control room were able to determine relatively quickly, within 58 seconds, that breaker HR1 had opened, causing the low voltage blackout, and were able to manually restore power. Staff found that the loss of power to the low voltage bus led to a loss of lighting and machinery, including the main engine cooling water pumps and steering gear pumps, which resulted in a loss of propulsion and steering. Staff believes that the engineering crew's initial response to restoring LV power after the first underway blackout was timely. In the review of the Dali's machinery and electrical systems, the NTSB identified 4 safety concerns that, although not causal in the initial blackout, are related to preventing a loss of propulsion and recovering fully following a blackout. First was the configuration of the main engine to shut down due to low cooling water pressure. This automatic shutdown was configured during the construction of the vessel to meet the Classification Society rules at the time. However, current classification rules no longer require this shutdown, and the main engine designer does not specify or encourage it to be an engine shutdown. For the crew of the Dali to effectively steer the vessel, the main engine had to be operating, rotating the propeller, and providing wash across the rudder. When the main engine cooling water pumps shut off due to the initial underway blackout, the main engine automatically shut down moments later and was not restarted, severely limiting the vessel's ability to maneuver. Due to the dependence on vessel machinery with maintaining maneuverability, system redundancy is essential and is factored into vessel design. As cargo vessels evolve over time, it is important that technology keeps pace. Staff found that the as-built configuration of the Dali's main engine to automatically shut down due to low cooling water pressure met classification standards at the time the vessel was constructed. However, it endangered the vessel because it prevented the main engine from being available following the initial underway blackout, thus reducing the vessel's maneuverability. Staff proposes one recommendation to Synergy Marine Group and one recommendation to the U.S. Coast Guard. The second safety concern that, although not causal in the initial blackout, was the use of the flushing pump as a fuel oil service pump for the two online diesel generators. While the Dali was in Baltimore prior to the accident and during the accident events, diesel generators 3 and 4 were supplied fuel from a single standalone fuel pump, the fuel oil flushing pump. This pump shut off and stopped supplying fuel to the generators on March 25th, when a blackout occurred due to human error while the vessel was alongside the dock, and then again on March 26th while the vessel was underway following the initial underway blackout. As a result of this insufficient fuel supply, the online diesel generators began to stall and were automatically disconnected from the high voltage bus, which resulted in a second vessel blackout on both days. The flushing pump was not capable of restarting automatically when power was restored and required a manual restart, something that was not quickly done. According to the vessel's classification society, the operation of the pump as a fuel oil service pump did not meet classification requirements because it was not able to restart automatically. Staff found that the second underway blackout on March 26th and the second import blackout on March 25th, during which both the high and low voltage buses were lost, were caused by insufficient fuel pressure to the online diesel generators, resulting from the inability of the flushing pump to automatically restart following a loss of power. Further, staff believes that the crew's operation of flushing pump as the service pump for the online diesel generators was inappropriate because the necessary fuel pressure for diesel generators 3 and diesel generator 4 would not be automatically reestablished after a blackout per the fuel system's design. Synergy provided technical oversight, assistance, and guidance to its vessel operators through several means. The Dali was equipped with a remote equipment monitoring system, which allowed Synergy's technical superintendents and managers to monitor real-time vessel operations, data, and analytics. Also, these Synergy experts were in touch with the Dali's crew at least daily, via email or phone. Further, a team of experienced Synergy technical managers and superintendents provided oversight to Synergy's vessels through biannual vessel inspections. These comprehensive inspections lasted a week or longer and covered a broad range of areas and topics, including the vessel's machinery and electrical systems. Despite this, Synergy was unaware that the flushing pump was being used as a standalone fuel oil service pump on the Dali and at least one other Synergy-operated vessel. Staff found that Synergy's operational oversight was inadequate because it did not discontinue crew's ongoing use of the flushing pump as a service pump for the diesel generators aboard the Dali and at least one other vessel. Staff proposes one recommendation to Synergy Marine Group. The third safety concern related to the recovery from a loss of power was the operation of the vessel's low voltage step-down transformer, high voltage breakers in manual mode rather than automatic. The Dali's low voltage bus was connected to the high voltage bus via 2 redundant step-down transformers. The high voltage breakers, HR1 and HR2, which linked to these step-down transformers, had 2 control modes, manual and automatic. Synergy left the configuration of these breakers to the vessel's crew's discretion. as did the classification society of the vessel and the original equipment manufacturer, who provided no specific requirements or guidance on which control mode should be normally used. In practice, the two control modes were used to assist the crew in seamlessly changing over transformers for routine maintenance or operational purposes without having to black out the low voltage bus. An ancillary outcome of operating both HR breakers in automatic control mode, which was tested and confirmed by investigators following the accident, was that upon an unexpected trip of the connected HR breaker, such as the Dali's initial underway blackout on March 26, the vessel's other step-down transformer would automatically connect after about 10 seconds, restoring power to the low voltage bus. During maneuvering situations, response time is critical to avoiding an accident. Therefore, vessel systems should be configured to ensure maximum redundancy and the quickest possible recovery from the failure of critical systems. In this accident, the crew may have had critical systems available to aid in maneuvering sooner if the HR breakers had been in automatic. Staff believes that keeping the high voltage breakers control modes set to automatic rather than manual would not have prevented either underway blackout, but it would have shortened the duration of the initial underway blackout from 58 seconds to 10 seconds, providing more time for the crew to attempt to recover critical systems, such as propulsion, as the vessel approached the Key Bridge. Staff proposes one recommendation to Synergy Marine Group. Mr. Ginalone will now continue.
Thank you, Mr. Barnum. The fourth safety concern related to recovery from a loss of power was the effect of the emergency diesel generator radiator damper positions on the generator's ability to start. The Dali was equipped with an emergency diesel generator able to power essential onboard systems during a loss of low voltage power. Regulations required the generator to be able to automatically start and power the emergency bus within 45 seconds of the loss of normal low voltage power. However, during the accident, it took 70 seconds. For the generator to automatically start and power the emergency bus, it had to be in standby start configuration, something that the crew and pre-departure paperwork confirmed to investigators following the accident. Additionally, once the start sequence was initiated, for the generator to successfully start, the radiator damper, which was opened and closed automatically by means of a mechanical actuator, had to be fully open. The position of this damper was relayed to the starting controls of the generator by means of a limit switch. If the limit switch did not indicate fully open, the generator would not start. Staff found that it is likely that the emergency diesel generator's failure to connect and power the emergency switchboard within 45 seconds, as required by International Maritime Organization regulations, was due to the emergency diesel generator radiator damper actuator's limit switch not indicating open in the required time due to unknown circumstances. Staff proposes one recommendation to Synergy Marine Group and one recommendation to Class NK. This concludes the engineering group's presentation. Ms. Quinn will now discuss nautical operational aspects of the accident.
Thank you, Mr. Ginalone. This presentation will address the Nautical Operations Group investigative findings. This is a photo of the Dali underway, viewing the vessel's starboard side. The vessel's length overall was 984 feet, and the vessel's beam was 158 feet. Dali's design was a split house configuration. The forward house contains the navigational bridge and accommodation areas. The aft house contains the engine room and exhaust stacks. The anchors are located forward on the bow and must be operated locally. This hull marking indicates the bow thruster's location below the water. The graphic on the left shows the approximate locations of all personnel stationed on the navigational bridge. The bridge team consisted of the master, second mate, and helmsman. 2 pilots were also on board for departure. The picture on the right is Dali's bridge. The arrow points to the helm, where the helmsman steers the vessel. Despite the actions to control the vessel's heading, its path towards Pier 17 remained unchanged. The graphic on the left shows the vessel footprints from the first blackout to the pier contact. On the right, the waterway depths are shown. The dark blue is the channel, surrounded by shallow areas beyond the channel's boundaries. The vessel tended to starboard due to external forces acting on the vessel's hull, such as bank effect and the residual rate of turn from steering prior to the blackout. These forces were unable to be counteracted effectively using the available resources, as the propeller was not providing wash over the rudder. Staff found that the actions of the pilots and the bridge team in response to the emergency were executed in a timely manner, but the vessel's loss of propulsion close to the key bridge rendered their actions ineffective. On the left, there is a graphic comparing the size of a cargo vessel which struck the key bridge in 1980 to the size of the Dali. When the smaller vessel struck the bridge, it destroyed the pier fendering system and caused minimal damage to the pier and the vessel. The expansion of global trade is a major driver of increased vessel size. As the volume of goods transported across the ocean grew, the demand for larger vessels to accommodate the increase also grew. Operational environments expose these vessels in port and waterway infrastructure that was not designed to accommodate or withstand impact with the vessels of such size. Pier protection and emergency shutdown procedures were discussed by port stakeholders as early as 2 decades prior to the casualty. Staff found that larger vessels pose risks and challenges to maritime safety due to their reduced maneuverability and restricted waterways. The pilots had emergency shutdown protocol for the bridges in their waterway. The protocol was amended 23 days prior to the casualty. The active protocol instructed pilots to contact the Coast Guard as the single point emergency contact for shutting down bridges in the event of a potential strike. However, during the emergency, the former plan was followed. The senior pilot called his dispatcher, then the dispatcher called the MDTA and the Coast Guard. This system proved to be effective. Staff believes that the quick actions of the pilots, their dispatcher, and MDTA to stop bridge traffic prevented a greater loss of life from the bridge collapse. Staff proposes one recommendation to the Harbor Safety Committee's National Steering Team. I will now discuss safety management system aspects of this investigation. A safety management system, or SMS, is a systematic approach to managing safety, including the necessary organizational structures, accountabilities, policies, and procedures. An effective SMS can help organizations reduce and prevent accidents, the loss of lives, time, and resources. Proactive safety management, when done correctly, is predictive and designed to anticipate and address safety issues before they occur, and utilizes continuous data analysis to improve policies and procedures. In the maritime industry, the International Maritime Organization's International Safety Management Code, or ISM code, establishes the standard for safety management systems. The code prescribes 6 functional requirements. Under the code, vessel operators must define and document responsibilities and authorities relating to safety. They must develop detailed policies and procedures for key shipboard operations, including procedures for responding to emergencies and reporting accidents for all crew members to follow. Regular audits are required. In the aviation industry, the International Civil Aviation Organization established the framework for an aviation SMS. The 4 elements are: safety policy establishes senior management's commitment to continually improve safety and defines the methods and organizational structures needed to meet safety goals. Safety risk management determines the need for new or revised risk controls based on the assessment of acceptable risk. Safety assurance evaluates the continued effectiveness of risk control strategies and supports the identification of new hazards through data collection and analysis. Safety promotion includes training and communication regarding the SMS and other actions to create a positive safety culture within all levels of the workforce. When comparing the two models, some elements of the four-component aviation SMS framework are not included in the Maritime ISM code requirements. For example, safety risk management component of the aviation SMS code is a proactive obligation, while the ISM component for safety risk management is reactive. Proactive risk mitigation strategies in the SMS programs have been proven to increase safety by identifying hazards prior to their occurrence. The safety assurance element in the aviation model includes a change management model. The ISM model does not. Monitoring organizational change management helps mitigate risks by assessing how changes may affect safety. The safety promotion component in the aviation model includes the detailed communication and training requirements associated with implementing an SMS. The Maritime ISM model does not prescribe a formal means of safety communication. This means the ISM model does not require a model for how to communicate safety actions or changes in safety procedures. Because the ISM model does not specifically include this element, the possibility exists that mariners may not receive critical safety information. Staff found that the requirements of the ISM code includes some elements of a comprehensive proactive safety management system. However, the code does not fully encompass all four critical components of safety policy, safety risk management, safety assurance, and safety promotion. Staff has proposed one recommendation to the U.S. Coast Guard. This concludes my presentation. Mr. Payne will now discuss vessel voyage data recorder related findings.
Thank you, Ms. Quinn. This presentation will discuss issues related to the usage of voyage data recorders. A voyage data recorder, known as a VDR, is an electronic system installed on large vessels that continuously records navigational data, radar images, chart plotter information, basic engine operation, alarm statuses, bridge audio recordings, and VHF radio communications. A VDR is mainly three parts. A VDR cabinet, which is the VDR's main computer and storage system. It is inside the ship and contains at least 30 days of data. A VDR protective capsule is stored on the exterior of the vessel, which is designed to survive damage and sinking. It records a minimum of 48 hours of vessel data. Last, newer ships are required to have a float-free combination rescue beacon, which also functions as additional VDR storage. During the investigation, we encountered several problems that made it hard to extract and use the VDR data efficiently. Key issues included unrecorded data during the vessel's first underway blackout, the lack of recording of communications between the Dali's bridge and the Dali's engine room, the digitally destructive mixing of recorded bridge audio channels, inadequate VDR playback software, the inability to download the full data set on board the Dali, and the complex workflow for processing proprietary VDR data in the common formats. Overall, current VDR performance standards don't fully address how required software should function for users who review the data, which creates delays to investigation and limits the usefulness of the VDR to make a timely impact on safety issues. VDR standards mandate that only bridge audio is to continue to be recording during a power loss. Under normal power, the VDR records information streams such as bridge microphone audio, the ship's engine and rudder operation, GPS position, AIS automatic identification information system, and chart plotter information. However, when the ship blacked out, only bridge audio was recorded. The other signals, like GPS position, were still sending data, but their own requirements state that they must remain powered by their own batteries during a blackout. The VDR did not record these powered signals. As a result, investigators had to rely on other external shoreside data to plot the Dali's movements. When asked about this issue, the manufacturer of the VDR stated that, quote, "The other items are not recorded because they are not required to be recorded." During the accident, the Dali bridge and the Dali's engine room teams communicated via an internal telephone system that stayed powered during the blackout. The VDR did not record and was not required to record this communications line. Only the Dali bridge side of the conversation was captured by the microphones. Because the crew had survived, investigators were able to corroborate the details through crew interviews and these one-sided recordings. During the blackout, the VDR continued to record audio from the Dali's bridge microphones, but the quality was degraded by numerous alarms that were triggered. VDRs record audio in mono format. Mono mixes audio channels in a way that can't be reversed. This is called destructive mixing. Alternatively, stereo mixing mixes audio channels in a way that can be reversed. This is called non-destructive mixing. The diagram shows the placement of the microphones on the Dali, and the color lines show how the mics were connected digitally. Microphones sharing a color were mixed as mono. Because mono audio cannot be separated, alarms near one microphone can obscure conversations elsewhere, making it difficult or impossible to determine what the crew said during an incident. Current VDR standards allow destructive mono mixing. A lack of defined specifications for playback software creates challenges for safety-related users. For example, the software on the Dali's VDR could not perform a full download of the VDR dataset, forcing the removal of the VDR and for download at the manufacturer's facility. VDR software also lacks many basic features to review data. The audio playback feature is primitive and does not allow the user to rewind in short increments. Recorded vessel data cannot be displayed in basic graphs either. Because the software lacked these features, analysts are forced to export the data, but the VDR standards do not define any acceptable methods to do this either. For instance, the Dali's VDR exports audio in tens of thousands of short files instead of a simple continuous recording. The VDR standards allow these types of illogical protocols. Because of these issues, investigators must rely on alternative means of playing back VDR data. The practice has become so commonplace that investigative authorities around the world share and maintain a database of alternate VDR software. The standards for VDRs are two parts. First, performance standards, which generally outline VDR specifications. And second, technical specifications, which address the technical details of the VDR systems. The International Maritime Organization, IMO, sets the overall VDR performance standards. The International Electrotechnical Commission, the IEC, develops the VDR technical specifications for VDR manufacturers to follow. The IEC develops technical standards that the member states or countries agree meet the IMO standards. In the United States, the U.S. Coast Guard is the U.S. representative to IMO. On the technical side, the American National Standards Institute, or ANSI, is the U.S. representative to IEC. Staff has found the VDR was designed to shut off data during the blackout despite the availability of important incoming data streams. Bridge and engine room communication were not required to be recorded. The VDR standards allow independent bridge audio recordings to be destructively mixed, which worsens the quality of the audio. VDR standards do not define any performance requirements for VDR software to be useful in a real-world environment, and VDR users often seek alternate methods of playback. Staff has proposed one recommendation to the American National Standards Institute and one recommendation to the U.S. Coast Guard. This concludes the Recorders Group presentation. The Bridge Structures Group Chair, Mr. Parent, will now discuss the bridge aspects of the accident. Thank you.
Thank you, Mr. Payne. My presentation will first discuss the urgent recommendation report and recommendations issued in March 2025, including the lack of vulnerability assessment for the Key Bridge and the more widespread issue of the lack of vulnerability assessments for other bridges frequented by ocean-going vessels. Next, I will discuss the need for motorist warning systems on bridges. And lastly, I will address the highway workers on the bridge when it collapsed and the need for effective and immediate communication. The overall length of the continuous steel through truss bridge was 9,086 feet, and the bridge had a maximum vertical clearance of 185 feet within the main navigational channel over the Fort McHenry Federal Channel. The Key Bridge was designed according to the 1969 American Association of State Highway and Transportation Officials, or AASHTO, standard specifications for highway bridges. These specifications predated the regulatory requirements for bridge protection systems from vessel contacts. Despite not being a requirement, the Key Bridge was originally designed with pier protection systems for piers 17 and 18, including 4 dolphins shown by the yellow circles and pier fendering systems shown by the yellow rectangles. However, the pier protection systems had not been evaluated to consider impacts by today's ocean-going vessels. The bridge and pier protection were subjected to regular safety inspections in accordance with the National Bridge Inspection Standards, and the most recent inspection prior to the collapse resulted in a satisfactory rating. As a result of the NTSB investigation and recommendations after the 1980 collapse of the Sunshine Skyway Bridge in Florida, the Federal Highway Administration, or FHWA, drafted a proposed design code to evaluate bridges for vessel collision, which led to the 1991 adoption of the AASHTO Guide Specification and Commentary for Vessel Collision Design of Highway Bridges. While FHWA requires that new bridges on the National Highway System be designed to minimize the risk of catastrophic bridge collapse from vessel collision, they can only recommend these vulnerability assessments be performed on bridges designed before the release of the guide specifications. It's important to note that the intent of performing vessel collision vulnerability assessments on existing bridge systems is to identify structures that are particularly vulnerable to catastrophic collapse, thereby allowing bridge owners to be aware of the high-risk safety needs requiring immediate or short-term action, as well as information to prioritize the long-term needs for bridge rehabilitation or replacement. The guide specifications references 3 methods for conducting vulnerability assessments: Method 1, Method 2, and Method 3. Bridges over navigable waterways with commercial barge and ship traffic should be evaluated using a vulnerability assessment in accordance with Method 2. The Maryland Transportation Authority, or MDTA, had not performed the AASHTO Method 2 calculations prior to the collapse of the Key Bridge to determine the bridge's vulnerability as recommended by AASHTO in the guide specifications. As part of the NTSB's investigation, we performed the AASHTO Method 2 calculations to determine vulnerability to collapse for the Key Bridge and found that prior to its collapse, the Key Bridge was nearly 30 times above the AASHTO acceptable risk threshold. As a result of our vulnerability assessment for the Key Bridge, we were concerned there might be other bridges that could be vulnerable to catastrophic collapse from impacts by ocean-going vessels. We worked with the FHWA and identified bridges across the nation that cross navigable waterways used by ocean-going vessels. Ultimately, we identified 68 bridges over navigable waterways frequented by ocean-going vessels within 19 states as having an unknown level of risk of collapse. In our March 2025 urgent recommendation report, we found that if the MDTA had calculated the risk of collapse for the Key Bridge prior to its collapse, the MDTA would have identified that the bridge's risk level was almost 30 times greater than the AASHTO acceptable risk threshold for critical or essential bridges. Further, the MDTA would have had information to proactively identify strategies to reduce the risk of a collapse and loss of lives associated with a vessel collision with the bridge. The 30 owners of the 68 bridges over navigable waterways frequented by ocean-going vessels are likely unaware of their bridge's risk of catastrophic collapse and a potential need to implement countermeasures to reduce the bridge's vulnerability. In that report, we issued 2 urgent safety recommendations to the FHWA, the U.S. Coast Guard, and the U.S. Army Corps of Engineers. These 2 recommendations called for the formation of an interdisciplinary team comprised of experts from the 3 agencies to provide guidance to bridge owners on evaluating and reducing the risk of a bridge collapse from vessel collisions. We also issued 2 urgent safety recommendations to the 30 bridge owners to calculate their bridge's vulnerability to catastrophic collapse and inform the NTSB if their risk is above the AASHTO threshold, and if above, to develop and implement a risk reduction plan with guidance and assistance from the interdisciplinary team that includes short and long-term strategies to reduce the probability of collapse from a vessel collision. I'm pleased to report that we have received positive responses from every recipient of the urgent safety recommendations. The next issue area I will discuss is the need for a motorist warning systems on bridges. Since the 1970s, the NTSB has investigated multiple bridge collapses involving injury and death to motorists that were either on a bridge when it collapsed or drove into the void created after the collapse. 3 examples are shown here, including the 1980 collapse of the Sunshine Skyway Bridge in Florida, the 2001 collapse of the Queen Isabella Causeway in Texas, and the 2002 collapse of the I-40 bridge in Oklahoma. In 1983, in response to NTSB recommendations after the Sunshine Skyway Bridge collapse, the FHWA issued a technical advisory titled Peer Protection and Warning Systems for Bridges Subject to Ship Collisions. The advisory acknowledged the need to consider protection for bridge piers as well as warning systems to alert motorists in the event of a collapse. AASHTO incorporated motorist warning systems into their 1991 guide specifications. Technologies identified in the technical advisory were included in a motorist warning system installed on the repaired Queen Isabella Causeway Bridge after its collapse. The system included a continuous fiber optic cable for signal transmission as shown by the arrows. In the event of a collapse, a loss of signal would be detected and the motorist warning system would activate. Primary motorist warning is accomplished through a series of flashing red traffic signals, circled in yellow, which are configured to notify motorists who have not reached the site of the bridge collapse to stop, and to allow those who have already passed the site to exit the bridge. Warning mechanisms, marked by the yellow arrow, include signs alerting motorists when they approach the bridge, traffic gates, dynamic message signs, and preemption of nearby traffic signals. Staff found that in lieu of police officers or highway workers charged with traffic control and capable of quickly stopping traffic, motorist warning systems designed to warn and stop motorists from entering onto a bridge are a possible countermeasure that can be quickly implemented to save lives and may be a component of an effective bridge protection strategy. For this reason, staff proposes one recommendation to bridge owners with bridges above the AASHTO threshold or who have not yet completed their Method 2 calculations. Staff also found that the owners of bridges over navigable waterways frequented by ocean-going vessels would benefit from updated guidance on motorist warning systems, including incorporation of a hazard alert and sensing technologies capable of detecting errant vessels and bridge movements that would indicate a need for a bridge closure, and systems that would both warn and prevent motorists from entering a bridge once a threat is detected. For these reasons, staff proposes 2 recommendations, one to AASHTO and one to the FHWA. My last issue area will address the highway workers that were on the bridge when it collapsed. There were 7 highway workers and 1 inspector on the Key Bridge performing roadway repairs as part of an MDTA contract. Prior to the collapse, the inspector was walking on span 22 near his vehicle, and the highway workers were on a break and were all sitting in vehicles. 2 of the vehicles were on span 20 and 4 were on span 18. Although unknown to the workers, spans 16 and 23 were the closest points of safety for them to escape to before the bridge collapsed. The shaded area shows the portion of the bridge that collapsed into the water below. As a result of the collapse, the 7 highway workers and all vehicles fell into the water, along with the collapsed section of bridge. 6 of the workers were fatally injured and 1 sustained serious injuries. The inspector was able to run to the safety of span 23 before the collapse. The highway workers on the bridge did not receive advance warning of the impending impact between the ship and the bridge. The MDTA contract for the work being conducted included a traffic control plan that required the contractor to provide a means of communication to the MDTA police detachment as a safety requirement. The contract specified acceptable forms of communication such as a mobile telephone, a citizens band radio, or a portable two-way radio. Prior to the start of the maintenance activities, the inspector exchanged cell phone numbers with the MDTA police officers that were providing traffic control for the work being conducted, thereby meeting the requirements of the contract. Staff examined the timeline of events leading up to the workers becoming involved in the collapse of the bridge. We found that 2 minutes and 25 seconds before impact, the pilot's dispatcher called the MDTA duty officer to notify them of the need to shut down the Key Bridge. 1 minute and 16 seconds before impact, the MDTA duty officer radioed the police officers performing traffic control to shut down all traffic lanes. 48 seconds before impact, the police officers blocked all traffic from entering the bridge. At 1:29:09 a.m., the starboard bow of the Dali impacted Pier 17. 13 seconds later, the pier collapsed, and shortly after, the other piers and spans collapsed. Despite previously exchanging cell phone numbers, the police officers did not call the inspector to warn him of the Dali's emergency. Instead, one of the officers planned to drive to the worker's location on the bridge to advise them once he was relieved by another officer. Had the highway workers been notified of the Dali's emergency at the same time as the MDTA police officers, there would have been about 1 minute and 29 seconds to evacuate before Pier 17 collapsed. All of their vehicles were parked facing south within the closed right lane of the bridge. Therefore, their likely route to evacuate from the bridge would have been to drive south, as shown by the arrow. Unknown to the workers, span 16 would have been the closest point of safety, which was 2,928 feet away from the northernmost highway worker. The American National Standard Institute Standard A1047 applies to workers engaged in construction, utility work, maintenance, or repair activities on any area of roadway. This standard includes provisions for pre-job planning to determine appropriate needs such as safety controls, equipment, and traffic control plans. However, there are no ANSI standards for highway workers to receive emergency information before or during dangerous or life-threatening events within work zones. Staff found that had the inspector and highway workers been notified of the Dali's emergency situation about the same time the MDTA police officers at each end of the bridge were told to block traffic, the highway workers may have had sufficient time to drive to a portion of the bridge that did not collapse. Effective and immediate communication to evacuate the bridge during emergency is critical to ensuring the safety of bridge workers. For this reason, staff proposes one recommendation to the ANSI A10 committee. Thank you. This concludes my presentation. The staff is ready to answer any questions you may have.
Thank you very much, Captain Muse, Mr. Giannalone, Mr. Barnum, Captain Quinn, Mr. Payne, and Mr. Parent for your excellent presentations. We are going to take, and I'm sorry, there's some issues with the streaming. So people who are tuning in virtually are unable to watch. So we're going to take a 20-minute break so that we can reset the system. And so, we'll just do 5 after 11. So a little less than 20 minutes. And then we'll come back and deliberate. Thank you very much, and thank you for your patience, everyone. And thank you again to the staff for your excellent presentations. We're going to get into some of your work. We'll turn to board member questions now, focused on the major safety issues that we identified in the investigation. For the first round, we're going to discuss engineering. In the second round, we're going to cover ship handling and communications. In the third round, we're going to focus on bridge vulnerability and highway workers' safety. In the fourth round, we're going to discuss voyage data recorders and safety management systems. We'll have a final round for any other questions we want to ask about any other safety issue or additional questions on the safety issues we discussed. And the purpose of this discussion is to highlight those areas where we believe we can make the biggest difference to improve safety. So with that, I'm going to begin with a discussion. We're going to begin the discussion on engineering, and I'm going to start with Mr. Barnum. And just for you all, our investigators routinely accomplish the impossible. And this investigation is no different. Certainly our parties are also key to our investigation. The Dali is almost 1,000 feet, and it's as long as the Eiffel Tower is high, with miles of wiring and thousands of electrical connections. Locating a single wire that is loose among thousands of wires is like looking for a loose bolt in the Eiffel Tower. So, Mr. Barnum, can you talk about your work, certainly your work with the party, but the extensive and meticulous work to find a loose wire? And you can have my entire 5 minutes. I see my clock wasn't started. You can have the entire time.
Thank you, Chair. And you are correct. This was an extremely challenging investigation. Myself and Captain Quinn were among the first people on board directly following the casualty. That's where the work really began. But, the nature of international shipping, this is rather typical, this type of vessel. The vessel was owned by a Singaporean company. It was registered to a Singaporean flag state. It was managed by a company predominantly composed of Indian nationals, as well as the crew were from India. The vessel was built in Korea. The vessel was classed in Japan. The engine manufacturer, the licensor, was a German company. The engine controls were a Kongsberg company. And the accident obviously was in America. So that was the first challenge to overcome, is setting up our parties, our groups. We were able to do that, and it's really a testament, I believe, to our party system, which was crucial in this incident. Everybody within the party was extremely helpful and supplied expertise. So that's that part, and then naturally we moved to the trying to determine why the vessel blacked out. It was a mystery to the crew on board at the time. They were extremely helpful. Often in these types of casualties, the vessel was moved to a dock, or it sinks or is damaged. But in this instance, the crew remained on board. The vessel had to be continually manned and operated, so they were there the entire time. They were able to assist us in our troubleshooting. When we initially formed our group, we didn't necessarily have the appropriate people, but because we didn't know what happened. But as we narrowed our search into HR1, trying to determine why it unexpectedly opened, we were able to coordinate with Hyundai Heavy Industries, the manufacturer of the vessel, and the high voltage switchboard, and they were able to get us the technical experts that they needed. They faced challenges getting their people here, but eventually were able to do that. Another impediment to determining the cause of the blackout was the manner in which it failed. This was an intermittent electrical failure. So meaning it didn't fail all the time. We saw in the animation that once the breaker opened and the wire became disconnected, it again reconnected. So following the blackout, we attempted to reclose HR1. It actually did not reclose, most likely because the wire was disconnected at that time. So we ended up getting additional support from HHI, high voltage breaker experts. And when they came, we tried the test again, and it worked. So we were chasing the fault for a while. We ended up having to leave the system configured the way that the system was configured during the casualty events. We let it set for a couple days, and sure enough, the fault occurred. The wire became disconnected again, and we came back on board and tried to identify why that happened. It took another team of specialists from Hyundai that came over, and we hooked up specialized equipment to monitor the electrical outputs of the switchboard. And we tested again the functionality of HR1 and other electrical circuitry. The fault didn't reoccur. The system worked. So again, we were left trying to troubleshoot it. We let it set again, and again it failed a couple days later. Eventually, we were able to analyze that data that we had received from the specialized equipment that was hooked up. And another visit, we were able to, with the help of naturally HHI, the crew, Synergy, and our other parties, find this single, loose signal wire in a cabinet that was not directly associated with HR1. It was actually in an ancillary cabinet, several cabinets away, just for convenience. Most likely during construction, that was the closest spot where they could connect these two wires. But the HHI technician was checking each wire point to point, and he was able to identify that this wire had become disconnected and was loose. He reinserted the wire, and we tested the functionality of the breaker. It tested satisfactory, and we simulated a disconnection. So we actually removed the wire while the breaker was closed, and it simulated a blackout. It occurred. The same thing that occurred during the casualty events occurred again. The breaker opened, and the LV bus blacked out. So I hope that answers your question of the complexity and the challenges that we faced and why it took us so long to determine the probable cause there.
Yeah, excellent work and very meticulous. I'll turn it over to Member Graham.
Thank you, Chair. And before I begin, I too want to express my condolences to the families and loved ones of those who lost their lives or who were injured in this terrible tragedy. I also want to thank the investigative team for their tireless work on a very complex accident, and I appreciate all your work. I appreciate you working with me on the draft report and my staff. Thank you so much. I'm going to go off a script just a little bit, off the engineering, but I think it's important for everybody to understand a little bit about what's happened with ships in the last 10 or 15 years. One of the items in the docket for this case, which is referenced in this report, is a study done by one of our specialists, Dr. Brittany Rawlinson. It looks at how dramatically vessel sizes have increased in recent years and the risk associated with those larger vessels. Staff, can you explain the effects of both containerization and the Panama Canal on vessel size increases?
Thank you, Member Graham. The containerization has been going on for 50-odd years now, but what's new in the last 10 years is the expansion of the Panama Canal, which is allowing much larger ships to reach the U.S. East Coast from Asia, up to 1,200 feet long and 160 feet wide. And for reference, Dali is 200 feet shorter than that. So these larger ships are subject to, they have a bigger sail area, which is affected by wind. They need larger turning radiuses. They have longer stopping distances. And they're affected by shallow water effects a little bit more. So all those things are affected by the larger ship.
Great, thank you for that. I want to focus specifically now on the Port of Baltimore and all the ports nationwide. If you could please, if I could ask that this study, which was in the docket, item number 188, be pulled up and show table 1 from page 6. There you go. This study analyzed the total weight of all vessels and containerized vessel imports and exports from all U.S. ports and the Port of Baltimore from 2013 to 2023. While the change in the total weight from all imports and exports nationwide grew by 16.7% over this period, and that's not an insignificant amount, but I could not believe that the Port of Baltimore specifically saw a 71.7% increase over nearly a decade. The problem, as this study points out, is that while ship sizes and weights are increasing, the infrastructure around them, especially in and around ports, is not keeping pace to accommodate those changes. This is introducing new risks to not just marine safety, but infrastructure safety in this country. The study specifically cites how the growth in vessel size has increased the risk of contact with port infrastructure due to maneuverability challenges associated with piloting large vessels within infrastructure that was not designed to accommodate their size. This study outlines several mitigation strategies that can be implemented to address these challenges. Can you please outline these strategies, what each entails, and how they would specifically help mitigate the known safety risk of larger vessels?
Thank you, Member Graham. What we would like to do is for the ports to use the AASHTO formula, and Mr. Parent will discuss that, I think, a little bit later, the details that are in there. There's a number of mitigation tools available that can go into that formula, which quantifies the risk. And to bring that down, the vessel size is one, vessel speed is another. The geometry of the channel is a good one you can use to reduce your risk. The use of tugs is one. There's a long list of variables in that formula. That's what we're encouraging ports to use to quantify the risk and bring it down.
And you think mitigating these risks will decrease the risk of contacts like these? Okay, I also note that these risks by larger vessels could be addressed through a comprehensive safety management system in the marine industry, and I'll get more into that in round 4. Thank you.
Thank you. Member Chapman.
Thank you, Chair, and certainly I join in expressing condolences on my own behalf and all of us at NTSB to the family and friends of those who were lost or harmed by this accident. We're going to do everything we can to make sure that this doesn't happen again. And to our staff, it is just so impressive, the work that was done to locate the source of the first underway blackout and then narrowing the search to a loose wire that at times became electrically disconnected. It's just incredibly impressive. Mr. Barnum, you talked about how long it took you all to find that. I think it's remarkable that you were able to find the source of the problem in such a short period of time, in my own opinion. It's just amazing work. I do have a question, and I think this one is for you, Mr. Barnum. What is an undervoltage release, and also how can a single loose wire cause a blackout?
Yeah, certainly, Member Chapman. Yes, it is an engineering group question, but I'm going to ask Mr. Ginalone to field that one. Thank you.
Thank you.
Thank you, Member Chapman. Undervoltage release, that is an electrical mechanical device that mechanically, when de-energized, mechanically disconnects a breaker. So in this case, HR1. The device requires to be powered at all times, and when it's de-energized and initiates the trip, it also will prevent the breaker from closing again. The second part of your question was how could a single loose wire do this? It was this specific wire and its location was the reason why the breaker tripped. That loose wire was in series with the UVR that I just explained. It needs to be energized at all times to keep the breaker closed, and also, when de-energized, it will open. So had it been a loose wire somewhere else, it could have been an indicator light that flickered. It just so happened to be in a location that energizes UVR, sir.
So it's not that any old loose wire on board a giant ship like this is going to cause this sort of a problem. This one just happened to be in a critical location. And just to kind of put in layman's terms, the undervoltage release is what a layperson would refer to essentially as a circuit breaker.
It is a device that will open a circuit breaker or close it without a human.
Okay, very good. And what is the, we heard discussion of the terminal block and the wires being inserted into the terminal block. What is the function of a terminal block, and is this something that's commonly used?
It is commonly used, sir. Function of it, it's an efficient way to tie two wires together. Instead of using a wire nut like you do at home and a light switch, you use a terminal block.
Okay. And if you could just reiterate, what did you find when you examined wire 1's connection and terminal block 381?
Member Chapman, I'd like to pass that to Ms. Lamb.
What we found was different contact marks and wear patterns on the wire 1, and we compared that to wire 3 that was in the same terminal block, as well as sister wire from a sister ship, also in Synergy's fleet. And we obtained some unused terminal blocks and wires and activated them independently and marked that, so we could see what typical damage was and compare that to what we saw on the accident vessel evidence. And then that way we could determine position and what was abnormal.
Thank you. And you very kindly put together these little examples for us. This is a real terminal block, as I understand it.
Correct. That is the exact make and model that was on board the Dali. It is just an unused one that we obtained separately.
And each of us has one of these. And I have to say, until I saw this morning, I did not realize we're talking about a very small component here. And this is what caused all the problems. The poor connection within this terminal block is what started the sequence of events that resulted in the blackout.
Correct.
Yeah, thank you. Thanks very much. I have some additional questions in this area, and I'm going to hold till the next round. Thank you, Chair.
Thank you very much. And did we determine, outside of the label banding that prevented it from being secure, why it became loose? Like what loosens it?
Yeah, Chair. So like you had mentioned, the wire label banding increased the circumference of the ferrule insulated collar and prevented it full insertion. So we found that the ferrule was only inserted just, and the spring gate clamp only grasped the very tip of the ferrule, resulting in a very precarious connection. Now that connection was made likely 10 years ago during the vessel construction. So over the length of that 10 years, that wire, like all the other wires, was exposed to normal vessel conditions and vibrations. And at some time, we believe in the relative recent past, that wire, the spring gate clamp, the closing force exceeded the ferrule's precarious connection, and the ferrule became disconnected.
Yeah, and that's what I was looking for. We've seen the draft report, but a lot of people have not, so I'm just trying to raise some of these issues that to bring awareness. Would the crew have known about that in any way? We're talking thousands of wires.
That was certainly one of the areas we tried to determine. This failure in the way that it failed, the only way the crew would have known is if they were operating HR1 and TR1. So we attempted to determine when the last time that was in use, those two components. We determined that it hadn't been used for at least about 7 months. But prior to that, we couldn't find when the last time TR1 was in use. We do know that the number of times it was been in use, we were able to compare breaker counter readings. We know that it was in use relatively consistently to that of HR2 and TR2. So it had been used, we just don't know exactly when the last time it was used, and that would have been the only way the crew would have been aware outside some of the recommendations we have with respect to thermography.
And they had, is it standard that, or practice, that they would switch between TR1 and TR2 throughout the year? Maybe one?
So at the time of the casualty, Synergy did not have a policy to change over low voltage step-down transformers. Within industry, it is common to see that done about twice a year. Since the casualty, Synergy has installed a work order to do that, to change over those transformers twice a year.
Okay, and inspectors, would they have been able to identify any concerns with a loose wire through their inspections?
Certainly, we have findings and recommendations that speak to that proposed, but Synergy did have both a 60-month and a 60-day, I believe 30-day, 60-day. I'm sorry. They did have inspections that of the high voltage switchboard. We feel that those inspections weren't specific enough on how to inspect it. Therefore, that's what we recommend, that they incorporate a thermography survey into their SMS and their preventative maintenance system.
So the inspections were really focused on the terminal box, not on individual wires and loose wires. It would be very difficult and time-consuming to test every single wire and inspect every single wire. And then you could introduce, I believe we've talked about that in this draft, could introduce some safety risk if you're doing that.
Yes, ma'am. It was discussed in the presentations, but yeah, it's mostly a visual inspection. It can be harmful to the operator to be manually manipulating live wires. It can also be detrimental to those small signal wires. So that's why we feel that thermography is such a valuable option here.
So infrared thermal imaging, can you just talk about, so the class societies allow for that, the use of that. Is that used throughout the marine industry? And that's
Yes.
the end of my questions after that.
Yes, ma'am. It is a widely used method, yes.
I have a follow-up to that, but I'll go after these two. Member Graham.
Thank you, Chair. I want to move to redundancy and have a little discussion about that, and I want to thank the team for you fielding all my questions over the past few weeks on redundant systems. With my experience and background in aviation, redundancy is very critical on board an aircraft, and there's certification requirements and everything that have given aviation a good safety rating out there. But and I've learned this is one of the main differences between the marine industry and aviation. For example, the Dali did not have a second engine, but as the team has educated me on this, can you talk about all the redundant systems surrounding the main engine on board large vessels like the Dali to help people understand that the redundancy already exists?
Yes, sir. So like you said, the Dali did have vessel redundancy, machinery redundancy built into the vessel design, kind of like in three baskets. So initially, an engine's like the Dali, like you mentioned, a large slow-speed diesel engine that rely on electricity. Redundancy is built into that power generation. So the Dali had redundant generators, had 4 generators that could produce sufficient power. We discussed earlier that 1 generator was often sufficient enough to power the entire vessel, so 4 certainly was in excess. They also had a redundant ability for redundancy within their switchboards. They had redundant step-down transformers like we've discussed. They also had the ability to split both the high voltage and low voltage switchboards if for some reason one became inoperable. That's kind of your first layer and actually trying to prevent a blackout in the first place for redundancy. Secondly, you have redundant pumps. So large diesel engines require cooling water, lubricating oil, fuel oil to operate. Those are supplied via large pumps. On this vessel, they had multiple pumps that could be used. If one failed, another one would automatically connect. If power were to be lost and then regained, those pumps would automatically start. So that's kind of like the second layer of redundancy that this vessel had. And then third layer, you spoke about the single means of propulsion. Yes, there was 1 diesel engine, but this is a very, very large diesel engine that, if need be, you could actually take out, if one cylinder became inoperable, you could take that out of the formula and basically at a reduced speed, still utilize the engine to return to port or safe harbor with the remaining cylinders in use.
Thank you for that, because that was going to be my next question. What happens when you lose an engine? But there's a workaround for that too. A little different than what I'm used to, and I think most people are used to. Thank you for that. Are there different standards when it comes to redundancy for passenger ships compared to large cargo vessels?
Yes, in my knowledge, yes, it wasn't a direct issue that we investigated in this report, but yes, it should be noted that modern larger passenger vessels, their propulsion systems are different. Most of them are diesel electric propulsion systems, but there are return to safe harbor regulations in place that require these vessels that are built, I believe, after 2010 to be able to return to port safely in the event of the loss of one propulsor or one single propulsion system. They need to have a redundant one, and they're able to do that.
So they're able to return to port if they lose an engine.
Yes,
that's their requirement for passenger vessels, but not container ships.
Yeah, larger, modern passenger vessels, yes.
Yes, thank you. As we've already discussed, larger vessels pose an increased threat to the port infrastructure that was not designed for them. Given this increased risk, do you believe increased redundancy for critical systems such as the main engine and steering help mitigate these risks in restricted waters?
Yes, staff certainly believes that anything that can be done to increase redundancy is a benefit.
All right, thank you.
Member Chapman.
Thank you, Chair. Mr. Barnum, I think this is for you. Can you explain, please, just a little bit more about what is thermography, how it works, and why we're recommending, or will be recommending, why that would be helpful?
Yes, certainly. We can discuss that. I will ask Mr. Ginalone to discuss it.
Thermography is an infrared camera that an inspector can use. It monitors surface temperature, comparing it to ambient temperature in a space. It can be used for machines, electronic equipment. And in this case, we talk about the difficulty of inspecting thousands and thousands of wires. Thermal imaging camera can scan multiple conductors at one point and can identify a warmer conductor compared to its surrounding conductors.
So if you had a wire like this one that was not properly connecting, thermography would help you identify that so that it could be corrected?
It could, yes, sir.
Great, thank you. There's a lot of information in this report to digest, and with that in mind, I want to ask, and whoever's appropriate, please take this, if you could just discuss a little bit more some of the critical equipment with respect to the investigation, starting with what is a flushing pump, and why was it non-standard for the flushing pump to be being used as a service pump?
Yeah, so as used aboard the Dali, the fuel oil flushing pump was, as the name implies, a pump that could be used to flush the fuel lines. It's a maintenance pump. Large vessels like the Dali utilize different types of fuel that are used at different areas around the world. So in order to clean the lines between fuel usage, this pump could be used to help flush the lines out. I believe the second part of your question was asking why it was used? Is that
why was it non-standard to be used as a service pump rather than its intended function, which was a flushing pump?
Well, primary purpose is that, as class indicated to us, is that it would not restart automatically following loss of power and restoration of that power.
And there was no redundancy on the flushing pump, correct?
Additionally, that is correct. The flushing pump was a single standalone pump. It did not have a redundant pump. And
maybe you said this already. Do we know why they were using the flushing pump as a service pump?
What we could determine is that the flushing pump was being used. We interviewed, obviously, the crew aboard Dali at the time of the casualty. We also interviewed prior crew members, and they all said that, the chief engineers indicated to us that they suspected that the normal supply and booster pumps and the associated pipework with those pumps had been isolated for some time, and that they suspected that the fuel within the system had been contaminated, and that in order for them to use that system, it would need to be opened up and cleaned, a process that would take a couple days. So they opted just to continue using the flushing pump, which was in use when they boarded the vessel, and so they continued to use it.
And the problem here is that the flushing pump didn't automatically restart after the initial blackout. That then ultimately resulted in effectively fuel starvation to the two generators that were online. Once they didn't shut down completely, but once they essentially got to the point where they didn't have enough fuel to run at a speed to generate sufficient power, that then resulted in the second blackout, and things got very complicated at that point.
That is correct.
The name of this next device I want to ask you about, and I'll do this quickly because I'm running low on time, is obvious. The main engine cooling water pump. This is the pump that provides cooling water to the main engine. It was configured on board the Dali to shut down, for the engine to shut down after only 6 seconds due to low cooling water pressure. This pump shut down during the initial blackout. That then resulted in the main engine shutting down, correct?
That is correct.
And the main engine shutting down, of course, resulted in loss of propulsion and effectively loss of steering, because without propulsion, it's very difficult to steer a big ship like this, correct?
Yes, to clarify, it didn't affect the ability to move the rudder, but it did affect, yes, the ability
the effectiveness
to
of this, yes. And very quickly, was there enough time in the 4 minutes before the bridge impact to restart the main engine and regain propulsion?
We don't believe so, no. Just to put it in context, you now have been speaking longer than the Dali crew had time to respond and avoid the bridge.
And you're not just turning the key. Restarting that engine had to be done manually, and it would have required that it be done down in the engine room, correct?
It would have had to been a coordinated event, and there's time, I know the time is up, but there would have been a coordinated event between the bridge and the engine room. There was certain systems that would need to be restarted. They would be automatic, but there is time delays associated with them. It would have taken about 40 seconds for those conditions to be met, and then another roughly 40 seconds once the engine was restarted to achieve a sufficient RPM to sufficiently provide wash across the rudder.
Thank you. That's helpful. Chair, thanks. Sorry to go over.
Thank you. I'm going to continue on the flushing pump. And you mentioned that it had been isolated for some time. In 2020, when emissions requirements changed, and to comply with the requirements, Grace Ocean, with approval from the Classification Society, installed an exhaust gas scrubber system, which would clean certain pollutants from exhaust gas before being released into the atmosphere, allowing the vessel to burn heavy fuel oil in the main engine via diesel generators 1 and 2. Diesel generators 3 and 4 did not have a scrubber system installed, so they could only burn very low sulfur, heavy fuel, and marine gas oil, correct? Or just marine gas oil?
Mostly the generators 3 and 4 could burn low sulfur marine gas oil, MGO.
Yep.
And they could also, were configured to, they could burn low sulfur heavy fuel oil.
That's right. But the flushing pump was designed for maintenance, correct?
Yes, ma'am.
So the flushing pump in this situation was actually supplying the marine gas oil. Was there any evidence that there was a reliance on using the flushing pump for the use of marine gas oil to comply with emissions requirements?
That was certainly an area of our investigation. We looked into this. There is precedent for that. I can speak to it if wanted, about the regulatory requirements and the requirements on the crew. But the fuel flushing pump could only provide the engine with low sulfur marine gas oil. That's how it was configured. It could not take suction from the LS low sulfur fuel oil tank. The crew did not indicate that that was the reason why they were using the flushing pump, but that was, one of the shouldn't say reasons, but one of the methods of using it is that it could never be accidentally crossed over to a different type of fuel.
And so, and again, I'm certainly supportive of strengthening environmental regulations, but we have to also look at safety impacts and make sure there are not unintended consequences by use of some other configuration to comply with those emission standards. And we raised this very issue in the draft report. I do want to ask if the flushing pump was running before a blackout, a crew member would have to manually restart it, as we talked about, to restart it once power was restored. But to do that, where does the crew member who is likely in the engine control room have to go?
The crew member would have to go to the local station, the local start panel, which is located directly adjacent to the flushing pump, which is 3 to 4 levels down and to the side of the vessel within the fuel purifier room.
So to restart it, you have to go, it's 2 levels down in near total darkness with a flashlight from the engine control room on the 2nd deck to the purifier room on the 4th deck.
Yes, ma'am.
Yeah, okay. And can we talk, was the crew aware that they should not be using the flushing pump to supply fuel?
This is an item that we have a draft finding for. We certainly feel that they should not have been using it. We also feel that Synergy should have been aware that they were using it. And at the time, Synergy did not have any policies or procedures related to the use of the flushing pump. And we have a proposed recommendation that states that they should incorporate it into their SMS.
Well, in fact, we had found in the investigation that they had likely been using the flushing pump for at least 7 months. But also, Synergy should have known it was being used. But the crew, I have some concerns that how they would have known. This was the first contract with the Dali for this crew. They did not indicate their awareness at all that it shouldn't be used. There's no policies, there's no standards. And then the engineer, the chief engineer that preceded this crew also didn't know. So I do have some concerns about that, but I'm running out of time. So very quickly, I will ask, now that Synergy knows this was being used, they had a technical manager brief the crew, right?
Yeah.
Don't use it. Are there any corporate-wide policies or procedures saying don't use it? Have they written those?
No.
No, it's been 20 months, right? I mean, that's the reason you're a party to our investigation, so you should take that action. It's been 20 months. We're not talking about a regulation. We're talking about a corporate-wide policy to stop using the flushing pump, which has no redundancy whatsoever. Sorry, I went over time. Member Graham.
Not a problem, Chair, and I'm going to jump on that too. Do we know if Synergy knew the flushing pump was being used?
The representatives within Synergy that we interviewed following the casualty indicated that they did not know. As part of the investigation, we were able to review thousands of emails sent from the ship to shore. Contained within those emails, we found a couple from the previous chief engineer aboard the vessel that seemed to indicate or mention that the fuel system had been isolated for quite some time, and that was the reason why they were using excess marine gas oil, something that would indicate that the flushing pump was in use. So yes, we would expect that a knowledgeable Synergy technical person would be able to decipher that from within those emails, yes.
Thank you for that answer. I want to talk a little bit about MARPOL's emission regulations, since I believe there's a possibility these two issues are connected, in my opinion. Can you give a brief overview of what the International Convention for the Prevention of Pollution from Ships, or MARPOL, as it is known in the industry, what it is and what it entails?
Sure, and again, we could probably have a 200-page report just on that.
Yeah,
but
short answer.
Broad strokes. Yeah, so MARPOL, as you mentioned, is the international treaty that covers all pollution from vessels. So not only contaminants from an accidental or operational release of fuel or lube oil, but it also covers other hazardous materials. It covers garbage. It covers sewage as well. But in the context of this, Annex 6 in particular covers emissions. So within MARPOL Annex 6, it sets worldwide limits on what percentage of sulfur can be contained within your fuel oil and where that fuel oil can be burned.
Okay. Thank you for that. And that was in January 2020 when that Annex 6 came about. Is that correct?
Yes, sir, the current.
Okay. Do we know if they addressed or accounted for safety, or is it purely focused on emission regulations irrespective of safety risk or benefits?
Yeah, to my knowledge, Annex 6 is strictly concentrated on what parameters your vessel needs to adhere to with respect to the equipment that's operating, the engines, the exhaust gas scrubber systems, the different emission control devices used, also the fuel sulfur content. It doesn't take into account the potential effects on safety.
It doesn't take into account the number of times the crew has to switch fuel tanks and pumps to move the different types of fuels around, does it?
Not that I'm aware of. Synergy does have within their SMS, a technical manual with respect to fuel management. That manual is 162 pages as it is. It's pretty lengthy.
Do you think, in your professional opinion, that increasing the frequency of fuel switchovers increases the risk of unexpected or negative outcomes from such as mixing fuels or accidentally using the wrong fuels in the engine or the generators?
That's certainly an issue that we didn't necessarily think contributed here, but it is a well-known issue, and yes, I think that is a safe assessment.
I would like to emphasize my concern with these new emission requirements, which I believe have not adequately addressed safety concerns that would naturally arise from the substantial changes to vessel policies and procedures. Moving forward, I would hope that the IMO and the Coast Guard, as the U.S. representative of the IMO, will address these concerns rather than issuing blanket regulatory climate requirements that apply to international vessels. Thank you, Chair.
Member Chapman.
Thank you, Chair. The Dali was configured with a high voltage switchboard and a low voltage switchboard, correct?
Yes, sir.
And is that a common configuration for electrical systems on large ships such as this?
Yes, such as the Dali. They have a lot of refrigerated containers that obviously need to stay cooled and require a lot of electricity, and an efficient way to do that is utilizing these high voltage switchboards, yes.
Okay. After the vessel got underway, the first of the two blackouts was a blackout of the low voltage switchboard, correct?
Yes.
And that resulted in the loss of a number of important systems, important equipment, among them, first of all, the lights. So no, everything's dark, or most everything is dark. The cooling water pumps, that resulted in the main engine shutting down from loss of cooling water. The flushing pump, which we've been discussing, which not at this point in the sequence, but later on, resulted effectively in fuel starvation of the generators that were powering the system at the time. And also the steering gear pumps, correct?
Yes, sir.
Which had an obvious negative impact on steering, at least at that stage of the accident sequence. So I mean, now having pieced all of this together, we can see how this fit, but the crew would have been in the dark facing this inexplicable series of situations, all with a very, very short period of time to try to react.
Yes, sir, that is correct. And I think just one thing, if I could add, is as a vessel crew on a vessel when it blacks out, if you're in the engine room, your first reaction is to look at your generators and suspect that those were likely the reason for the blackout. They were able to identify that they still had the generators at this point and that something else had caused the blackout. Quickly, they were able to determine that it was just an LV blackout. Not only were they able to determine that it was just the LV blackout, they were able to manually close the 2 breakers needed to restore power relatively quickly.
And so they were successful then in restoring power to the entire ship fairly quickly, as you said. The problem was the damage had been done as far as losing propulsion and the flushing pump, and probably not all of that was apparent to them, at least initially, right?
Yes, sir.
The Dali also had an emergency generator and an emergency switchboard. There was some delay in that powering up. I believe it was configured to start up automatically, but the startup was delayed. First of all, what does the emergency switchboard power, and why was it delayed?
Sure, I'll ask Mr. Ginalone to answer that.
The emergency switchboard, it powers fire pump, some bridge equipment, lighting, life-saving equipment, a third steering pump. So the delay is supposed to start in 45 seconds. It ended up closing at 70 seconds. In order for the emergency generator to start in a standby configuration, it has to be set up that way. The ventilation dampers in the space need to be set to automatic. The engine control panel needs to be set to automatic, and the switchboard needs to be configured for that. At departure paperwork, crew indicated that these conditions were met. Post-accident interviews said that they'd left the engine in automatic. When staff found, looking for the reason why the emergency generator was delayed, we looked in their drawings and found that ventilation damper needs to fully open, allowing air to the radiator for the emergency generator to start. So what we call that is a permissive. It needs to happen before the next step can occur. And we have a finding related to that.
And that either didn't happen, or what's called the actuator limit switch wasn't indicating open, and that's what caused the delay startup of the emergency generator, correct?
That is correct. That permissive had not been met yet.
So either the damper wasn't open, or at least the system wasn't showing it open, and therefore the startup couldn't proceed until that occurred.
That's correct.
Okay, thank you. Thanks, Chair.
Sure. I want to go back to the flushing pump just for a second. So the March 25th second blackout and March 26th second blackout, both the same, one didn't lead to the other, both the same sort of circumstance, which was the flushing pump. Would the second blackout on March 25th normally be reported to the pilots from in-port to underway? Would that be something that would be part of a crew briefing or by the pilots when they came on, whoever the crew?
So, Chairwoman, if there was something that materially affected the ship or degraded the ship handling in any way, that would be required to be shared with the pilots. In this case, they didn't believe that the blackouts from the day before materially affected the ship. And we concur with that.
Correct. So we do concur with that. Yeah. So just really the last question. Do we know whether the Dali was the only one that Synergy used used a flushing pump to perhaps avoid emission standards or comply with emission standards on just the Dali or other ships?
We spoke to the chief engineer at the time of the casualty who had worked aboard other Synergy-operated ships. He indicated that he had used the flushing pump on other ships in an effort to compare Synergy operation. We did board the marine vessel Saison, sister vessel to the Dali, to inspect their configuration. This was done after the accident, so while we were on board the vessel, we did notice that they were not using the flushing pump on that vessel. But we do know through crew interviews that at least one other vessel had been using it, yes.
Okay, and is it possible that that other ships, that other vessels owned by entities other than Synergy could be doing the same?
Without verifying the machinery that they have on board, I couldn't say. I think staff certainly hopes that they are not.
Yeah, and exactly. And I just want to emphasize one more time that when we're talking about clean fuel and moving towards zero emissions, whether it's in aviation or any other mode of transportation, rail, marine, we have got to be very focused on unintended safety consequences of compliance using some other means. So again, that is just unfortunate. I'm going to turn to the main engine. The main engine obviously was configured for automatic shutdown due to low cooling water pressure. That was required by a German classification society when Hyundai built it. When the previous owner purchased it, they used a new classification society which didn't require the automatic shutdown. So Hyundai modified the configuration by making it a cancelable shutdown, meaning the crew could override the shutdown. And how many seconds did they have to do that?
It was configured with a 6 second delay. 6
seconds. And you and I were on another vessel recently, the Sirach. I mean, how many alarms are you talking is happening? I mean, there are so many.
Yeah, I mean, number might be low, but during the casualty, it was over 100 alarms.
Over 100 alarms. So 6 seconds to override the shutdown. Hyundai picked the 6 seconds as part of the design. And once you cancel, the engine remains running at 40%. In this case, of its rated speed. Its rated speed is 80 RPM, so the engine slowdown speed would be 32. Is it realistic to expect crew in this scenario to recover in 6 seconds?
No, it is not. And one addition to point to be made here is that the intention of that cancelable function is not intended for this immediate loss of cooling water pressure. That alarm, the operator is given there is a pre-alarm that's given. They're alerted by a low pressure alarm and then a low pressure alarm. It gives them time to start another pump. It's not intended for a loss of pressure that happens all of a sudden.
It's not intended for emergencies.
Not like this one.
Yep. Okay, thank you. Member Graham.
Thank you, Chair. Let's stay with that. So what would happen if we lose that cooling water? That pressure of the cooling water, what's going to happen to the engine?
The engines like these are configured with a cooling water head tank, so that it's a tank of water that's connected to the system that's located at an elevated level. So there is a minimum, as long as that head tank stays full of water, there is a minimum amount of pressure that will stay on the system. Without that water circulating through the system, however, the engine's going to begin to overheat.
Do we know how long it would take for that to happen?
It all depends on the load the engine has on it. I couldn't give you an exact time.
So do we know why, well, we did talk about why this engine was configured this way. Do we know of any other societies that are configuring engines this way?
we reviewed the other IACS membered classification societies at the time of vessel construction, and the only one that required this to be a shutdown was GL. So no.
So do we, is this a dangerous design feature for this engine?
We feel that it's an unnecessary shutdown. We feel that in this particular casualty, it endangered the vessel because it prevented them to have maneuverability. And we have recommendations to both Synergy and HHI to alert industry of this issue.
Okay. Is it easy for them to reconfigure this type of engine? Because they have it on other ships, is that correct?
Yes, sir. Yes, sir. In order to reconfigure a main engine shutdown like this, you likely need to receive class approval. That's something that could be done relatively easily. Once you have class approval to do so, you could get a technician out there and they could reconfigure the software relatively easily.
Is HHI aware of this?
Through this investigation, we have been in contact with HHI, and yes, they are aware of this.
Okay. Did they have a response to us on this?
Yes, we spoke to them about this issue and the best way going forward to help inform industry, and they felt that they were in a good position being the vessel builder and the configuration of the engines to identify which other engines are configured in the same manner, and then also they felt that they were in a great position to have correspondence with those vessel owners and advertise this issue.
Great, thank you. Thank you, Chair.
Thank you. Member Chapman.
Just a couple of last questions in this area, and thank you all very much for indulging us today. Can you talk just a little bit more about what are vessel classification societies, what's their role, and what's their authority?
Sure, Member Chapman. Class societies, firstly, they survey vessels to their standards, which they publish both during the design and construction and the operation of the ship. The vessels then issued a classification document or certification of class, it's called. There can be many different endorsements on there depending on what's required either by your customer or by your flag state. There's rules for steel vessels versus aluminum vessels versus periodically unintended engine rooms, a whole slew of different rules that you can ask for. Their other role is as a recognized organization on behalf of the flag state. So in this case, Singapore can delegate some of their statutory responsibilities to the class. And they will issue certificates such as load line certificates, the SOLAS Safety Ship Construction Certificate, safety management certificates are all issued by the class society on behalf of the flag state.
Thank you. And the draft report explains that the Dali fell under several different classification societies since its design phase. I think it was 3 different classification societies. Why is that, and how or why would a vessel owner choose a classification society or a different classification society?
Those are normally business decisions that are made by owners. Probably the biggest factor is just geography. If that particular class society has surveyors in the port where you're doing business or the shipyard that you're using, that's beneficial there. In some cases, the class society might have a technical expertise in some equipment that you want to use, and therefore you would use that class of society.
So it could be something as simple as just convenience.
Yes, sir.
But it might also have something to do with some technical issue where there might be an advantage going one way or another.
That's correct.
Thank you, Chair. I don't have any other questions in this area.
Thank you. I'm just going to read, just back to Member Graham's point, one statement by HHI in their letter dated November 12, 2025. HHI Hyundai Heavy Industries recommends, instead of addressing engine configuration or configuration in the Dali, that we focus on ensuring that all crew operators and captains are properly trained to understand the safety features and proper functioning of the vessels they are operating, which I think is a pretty poor response. Any comments on that?
No, I would agree with you there. We've already discussed about the intended purpose of that cancelable shutdown.
Okay.
It's not practical in the case of this accident.
Exactly. Okay, so no problems with the fuel. That was a question on scene. I just want to reiterate that. No problems with the switch over for the fuels or the fuel quality, correct?
No, ma'am, we excluded that early.
Okay. And you mentioned in your presentation that there were no warnings or alarms when the circuit breaker HR1 opened. Why? And were we able to replicate that in testing?
Sure. I'll ask Mr. Ginalone to address that.
That's correct, ma'am. There was no preceding alarms. The location of the loose wire that de-energized the UVR was in series with the same manual function if you wanted to open the breaker itself.
Great. And is there, just quickly, is there a standard for recovery time for a full vessel blackout like the Dali experienced?
For vessels such as the Dali, I believe regulations permit 30 minutes.
Okay, great. Really quickly, I'm going to go over to Mr. McMurray. And I appreciate the work of our parties. Parties to our investigation help us gain technical information that helps us in the course of investigation. They are not part of the analysis. They don't help develop our findings, our recommendations, or our probable cause, but they help us obtain the factual information throughout the course of the investigation. The advantage to them is they get information early so that they can take safety action and don't have to wait until the end of our investigation. I want to call attention to the Maryland Transportation Authority's party submission. Mr. McMurray, MDTA states in its party submission that some of the information that they include in their submission to us, some of it has been reported in the NTSB's public filings. Well, first of all, MDTA was a party, correct? Yes. So they had access to information, right?
Correct. Mm-hmm.
It then goes on to say, however, the bulk of the information herein comes from formal discovery obtained in the federal lawsuit that was filed by the owner and manager of the Dali, and that the state of Maryland is a party to that lawsuit. Is it appropriate for a party to rely on information from formal discovery in its party submission to the NTSB?
No, ma'am. By regulation, the purpose of the party submission is to provide input based on the evidence that's independently developed by the NTSB.
Yes. In fact, the regulation 49 CFR 831.14a states, in part, findings must be drawn from the evidence produced during the course of the investigation, not from litigation. So I'm pretty concerned about what was submitted. What I will say in this document, and just really quickly, because I'm probably going to run out of time because I will come back to this, did MDTA have any type of marine expert available for assistance in the investigation?
No, ma'am. The party reps for MDTA were two detectives and their engineer.
Yeah, and they did the best they could, and we certainly appreciate their support when we get to some of the response. They very clearly helped us with much of that. But I will say, if you look at our safety investigators in marine safety, they have over a combined 400 years of professional expertise in their field, and we're talking about, it's the Maryland Transportation Authority. Do you think it would be helpful if perhaps they had some marine safety experts on board or in their department, especially since they have so many, a number of bridges where vessels are transiting through.
I'm not sure if it would be valuable to have them on their own staff, but they were a party because they're technical experts in bridges and bridge construction and bridge protection. And that's the expertise we sought from them.
That is the expertise they have, but they participate in the interviews, including the marine safety interviews. So if they had a technical expert that could participate in that, that might have been helpful to them.
That's correct, Chair.
Yeah, thank you. Ran out of time. Member Graham.
Thank you, Chair. I just got a few questions to finish up this round for me, and it has to do with the terminal box inspections. Synergy required both a 6-month and a 30-month main switchboard inspections aboard the Dali as part of its preventive maintenance program. Is that correct?
Yes, sir.
Can you give a short overview of what the 30-month inspection entails?
That inspection is going to entail blacking out your high voltage bus. It's usually done during a shipyard dry docking period. You can open up the switchboard and do inspection of the bus bars for cleanliness. You can visually inspect for any signs of failure from within the switchboard.
Okay. How about the 6-month inspection? What does that entail?
That's a little less intrusive. Again, the instructions state one thing, the practicality is another. I believe they mentioned checking the terminals within the switchboard. That's just going to be a visual inspection, which can be very useful, can be very effective. A visual inspection of electrical components is a good inspection. We don't feel like it would have identified this wire. That's why we have proposed a recommendation in the field of thermography.
Okay. And when was its last 6-month inspection prior to the accident?
That inspection was completed relatively close to the casualty, I believe within the last 2 weeks.
I saw here March 23rd, 2024, so would that be 3 days before?
Yes, sir.
Wow. So did that really include conditions of the crimp terminals and renewing the crimp terminals if that was necessary? Or not?
The instructions did not give a proper guidance on how to inspect the terminal connections within the high voltage switchboard.
So do you believe the inspection guide from Synergy was insufficient in providing the detail in the inspection to successfully complete it?
Yes, I do.
You do, okay. Has Synergy changed their process or procedure since then for this inspection?
It's not. I'm not aware of that. They had post-casualty. They did hire a third-party inspector to come aboard the Dali and the 2 sister vessels to do a comprehensive switchboard inspection. That was completed. They found no additional loose wires or any other issues, but they have not updated their SMS to incorporate more detailed inspections. They have not, no.
That's very concerning. Thank you, and that's all I have in this round.
Thank you. Member Chapman.
No further questions. Thanks.
Thank you. And just going back to the MDTA's submission, because I just want to address some of their draft findings that they submitted, which and just get some responses to those. They state the first and second blackouts should have been reported to the U.S. Coast Guard. I believe they're referring to the March 25th blackouts immediately after the addressing of resultant safety concerns. Do you agree with that? Would that normally be reported to the Coast Guard?
No, we don't agree with that. Staff feels that those 2 blackouts did not materially affect the vessel's ability to get underway. They knew relatively quickly what caused those blackouts, so no.
Okay, and then another statement. They talk about aboard the Dali, operation and maintenance of the electrical system was performed by an unlicensed electrician who lacked the electrotechnical officer certification. And then they go on about the unlicensed technician. Did we have any concerns about mariner certifications or The electric, can you talk a little bit about the qualifications of the crew? Do we agree with that?
No, with respect to the electrician, he was a credentialed marine electrician. He worked under the guidance of senior engineering officers, including the chief engineer, who had a electrical technical officer's endorsement on his license. The crewing and credentialing of the crew aboard the Dali met the minimum safe manning requirements for the vessel as set forth by Flag State.
Thank you. And they also state the pilot card should have advised the pilots that the Dali had experienced the 2 blackouts within the past 11 hours, that the diesel generator 1 could not be started, that the hydraulic brake control on the port anchor was inoperable, the steering gear had not been properly tested, the online. Should that card have included everything we had seen?
I'll defer to Captain Quinn or Captain Muse regarding the pilot card.
So, Chair, no, that pilot card is more for ship handling and includes weather, how much chain there is on the anchor, those kind of things. Unless there was a deficiency that materially affected the ship and how it was going to handle, then no.
Speaking of chain and releasing of letting go of the anchor, how much time once it was let go passed? How much time right before collision? The VDR recorded it. You could hear the anchor chain.
I'll invite Ms. Quinn to answer that.
I believe about 2 minutes passed.
10 seconds.
10 seconds, excuse me.
And 10 seconds. Once that anchor chain was running, 10 seconds before the bridge collapsed. MDTA states that the anchor chain release could have prevented the striking of the bridge. 10 seconds. No way. So, again, I am disappointed that it violated our regulations, and they did not comply with our regulations. I am pleased that with the 2 police officers who participated with us, I met them. They did a great job, I thought. It's just not their expertise, but they were certainly very helpful with the bridge part, which we'll talk about a little bit later. I just would point one other thing in their party submission, which is that you know what, I'm going to hold this until we talk about bridges. So, any other questions? Any other questions? All right, we're going to move on to a second round of questions, this time focused on ship handling and communications. And I will start with Member Graham.
Thank you, Chair. I want to start with the communication protocols from the Maryland Pilots Association. And specifically on the focus on the ship and shoreside emergency communications briefly, and specifically the process by which the vessels communicate emergencies shoreside. In this case specifically, who should an emergency such as a blackout or a loss of control be communicated to shoreside, and how quickly should this communication occur, and what information should be communicated?
Again, I'd like to defer to Captain Quinn on this.
The speed at which you need to get shoreside response would depend on the capabilities of that specific port. In this case, it was immediate that they were able to contact their dispatcher shoreside, and their dispatcher was able to call the NDTA police and then call the Coast Guard.
So the pilot was able to contact the dispatcher pretty quickly then?
Yes, he called by cell phone.
Now that the dispatcher had received this information on March 26th, what was their next step, and what was that step supposed to be?
Procedurally, the standing protocol would have been to call the Coast Guard first on the ship. However, the senior pilot called his dispatcher, and the dispatcher called the police and then the Coast Guard.
And in this case, that was a good thing, right?
That's correct.
And why is that?
The response was timely and effective.
Okay, and they were able to get the police to shut shut the bridge down quickly.
Yes.
Otherwise, it would have continued. If they would have contacted the Coast Guard first, we don't know when they would have got to the MDTA. Is that correct?
That's correct.
So, now, how long had that procedure been in place?
It was changed 23 days prior to the casualty.
Okay. Have they changed it back to the original, or back to the other way of contacting the bridge?
Yes,
MDTA?
they have.
They have. Okay, that's a good thing. That's a good policy change. And I'm so thankful that they found that number before the Coast Guard number. Because what would the Coast Guard have been able to do at that point?
Based on the calls that were recorded that showed the Coast Guard's response, it seemed that the response might have been a little bit slower, for lack of better terms, in responding to closing down the bridge.
Okay, great. Thank you for that. I see got a couple minutes left on this round. I want to switch to focus on March 25th, the import blackouts on the Dali, and specifically, how were these communicated outside of the Dali? Were they communicated outside?
The two blackouts that occurred on March 25th while alongside the dock were not contacted at the time outside of the vessel, no.
Okay. Can you tell me a little bit about the smart ship alert system and how it works and how it's monitored?
So Smart Ship was a system that Synergy uses aboard their vessels to monitor vessel machinery, also vessel position and status, and different aspects. There is not a 24-hour continuously monitored system. When an alert or an event occurs aboard the vessel, it sends an automated email to a recipient. In this case, the recipient was a technical manager shoreside. It goes into their inbox, and whenever they review their emails, they can review these messages. The March 25th dockside blackouts did trigger an automated email that was sent to his inbox. At the time, that was not opened at the time. It was opened actually after the casualty. He reviewed that email.
Okay. And I assume that person probably is technically monitoring other ships in the fleet?
That is correct. He has several vessels under his supervision.
Okay. All right. I'll come back to this later. Thank you, Chair.
Member Chapman.
Thank you, Chair. Can you talk about bow thrusters, please? What are they and how are they typically used for maneuvering?
A bow thruster is a propulsor forward on the vessel, on the bow, and it provides lateral thrust at slow speeds. It's typically used at speeds below 3 knots. It's effective at speeds below 3 knots, and the Dali's bow thruster was not designed to be used above 5 knots.
And am I correct? Its intended purpose is for maneuvering in tight places, like docking and that sort of thing.
That's correct. Changing the vessel's heading at slow speeds.
And you mentioned that it's not effective at higher speeds. I believe the senior pilot did attempt to use the bow thruster to help maneuver the vessel. What were the circumstances there, and was it effective?
It was not effective. The bow thruster was not turned on. However, regardless of whether it was turned on or not, at that speed, it would not have rendered a valuable impact on maneuvering the vessel's heading.
And the availability of the bow thruster actually was impacted by the blackouts because I believe the pumps that provided power to the bow thruster were shut down at least at one point during the accident sequence. Is that correct? Do you know?
Yes, that's correct.
After the low voltage, the initial low voltage blackout, after that was corrected and power was restored, the steering gear pumps once again became available, but there was no propulsion because the main engine had shut down. Was steering effective without propulsion, and why or why not?
Steering is not as effective without propulsion, especially in shallow water. And the reason is you need a lift force across the rudder.
Yeah, so without propulsion, there was no essentially wash
Correct.
over the rudder. So the steering was, if not totally ineffective, at least not as effective as was necessary in order to maneuver under the circumstances.
Yes, that's correct.
Can you explain, please, what investigators found about why the ship veered to the right after it lost steering and propulsion, so that we can better understand what caused the movements towards the bridge pier? Because the ship did angle to the right towards the bridge pier as the blackouts proceeded.
Yes, I can, and I ask Mr. McClay, can you pull up slide 58, please, from the presentation? I'll start by explaining that when a ship is underway, its pivot point, which is the point that it turns around, is located approximately 1/4 aft of the vessel's bow. And so when a vessel is underway, there is positive pressure around the bow, and so that's bank cushion, and there's negative pressure around the stern. So here you can see in this graphic of the Fort McHenry Channel where both banks are, where it's in symmetry. Danny, if you can hover over that area, thank you. So when the vessel is in this area of the channel, the hull is in equilibrium, so it has positive pressure on both sides of the bow, and the vessel will continue to go straight. When the Curtis Bay Channel is introduced on the starboard side, there's a release of the positive pressure on the port side of the bow, which causes the vessel to veer to starboard. And the stern suction, which is a greater effect because the pivot point is forward and the ship acts like a lever, the stern sucks towards the bank and the bow pushes away from the bank, putting them on a collision course with Pier 17 of the FrancisScottKeyBridge.
Yeah, that's an excellent description. I've been I'm a pilot, not a very good pilot, but I've been thinking of it a little bit in terms of a phenomenon called ground effect. It's not exactly the same thing, but there's an interaction between the aircraft and the lift characteristics that is impacted by proximity to the ground. It sounds like this is a somewhat similar situation where essentially the forces on the hull are impacted by the pressures, the changing pressures as a result of the characteristics of the terrain around it, right?
Yes, that's correct.
Don't ask me to repeat that, I probably can't. Thank you, Chair. I have some more questions in this area.
Thank you, and I would just ask, bank effect has been a factor in how many of our investigations over the last decade? Does anyone know?
I think countless. We see it very frequently in the Houston shipping channel, but in that situation, it's when vessels are meeting and they use it to their advantage, but it is a very common cause of vessels grounding or hitting things faster than they would like to.
Yeah, and we picked up 9, 2010, 2011, 2012, 2 in 2015, 1 in 2016, 1 in 2019, 2022, and 2024. So I just point that out. Member Graham.
Thank you, Chair. I'm going to talk about the crew's response to the blackouts on the night of the accident, but let's first go back to the night before when there were 2 blackouts. While we know that the blackouts from the 25th were not directly related to the blackouts on the 26th, the night of the accident, and that's outlined in the report, I think it is still helpful for us to learn how the crew responded to a blackout on a vessel of this size. So on the 25th, when the initial import blackout occurred, how did the crew respond? Specifically, how did they identify the issue that caused the blackout, and how did they address that issue they identified?
So, important point here would be to mention that the vessel is in a very different operational status. So, while the vessel's alongside the dock, the engine room is unmanned. Crew are ashore or conducting maintenance. but they're not stationed in the engine control room like they were while the vessel was underway. They were standing by, ready to respond. So when the initial dockside blackout occurred, a member of the vessel crew was conducting maintenance. He inadvertently closed an exhaust gas damper associated with the single generator that was supplying power to the vessel. In doing so, it essentially stopped any exhaust from leaving the engine, causing the engine to sputter and stall, and was unable to produce sufficient power to power the vessel. So the automated power management system, sensing this failure of the generator, disconnected it, blacking out the vessel.
Okay. And then they determined that.
Oh, sorry.
Yeah.
Yes, so that was rather obvious.
Okay.
He knew immediately that his actions had caused the engine to disconnect and black out the vessel. To alleviate it, they reopened it. By that time, the automated power management system had connected another generator, so high voltage power had been restored. The crew had to manually close HR1 and LR1 to regain power to the low voltage switchboard.
Okay, so their recovery, identification recovery, was that per in accordance with policies and procedures they had in place?
Yes, I think their standard training for any marine engineer is to restore power as quickly as possible, and yes, they did that.
Okay. Now the second blackout, how did the crew respond to that one?
So the second blackout, as we discussed, was caused by insufficient fuel pressure. So in response to that first blackout, diesel generator number 3 was automatically connected. It did not have sufficient fuel pressure because the flushing pump was not restarted. So it eventually ran out of fuel, causing the second blackout. In response to that, they restarted the flushing pump.
Which was appropriate in this case?
Well, they restarted the flushing pump after the blackout. It was not in time. There was no company policy related to restarting a flushing pump following a blackout. We don't feel like there should be a policy on that because we don't feel like they should be running the flushing pump, and that's where our recommendations speak to.
Okay. But their response was timely to the second blackout, would you say?
Considering that it was an unmanned engine room at the time and minimal crew on board, yes.
Okay. And I guess in this case, it was appropriate since they were running off the flushing pump anyways?
No, I think, I think that speaks to the fact that staff does not believe that the flushing pump should be being utilized, whether in port or underway. So I don't think necessarily it was appropriate because they shouldn't have been running that.
Thank you. Now let's go to the night of the 26th. So the first blackout that night, how did the crew respond to that blackout? How did they identify the issue that caused the blackout, and how did they address it after they identified it?
So like we spoke to earlier, we feel like they responded in a timely manner. They were able to ascertain that it was just a low voltage blackout, not a complete vessel blackout. And they were able to manually close HR1 and LR1 to restore power to the low voltage bus.
And how quick did they do that?
58 seconds.
58 seconds. With hundreds of alarms going off?
Yes, sir.
Okay. Was there anything that the crew missed that they stated in their stated policies or procedures that indicated they should have done in a response to the initial blackout? Anything different?
No, other than, we feel that the flushing pump should not have been being used, and there was nothing in their SMS indicating or provided to them stating that it should not be used.
Okay, now how about the second blackout while underway? How did the crew respond, and was it appropriate and timely?
Yes, the automated power management system aided in the recovery. The second blackout was a high voltage blackout. The power management system automatically connected the standby generator within a couple seconds. So HV power was restored extremely quickly. LV power was restored I think within 30 seconds, so quicker than the first blackout.
Okay, so it was timely.
Yes, sir.
And for that configuration, was it appropriate?
No, the flushing pump is what caused the second blackout, so no, it was not an appropriate configuration.
Thank you. We keep hammering that home, don't we? All right, thank you.
Thank you. Member Chapman.
We'll be discussing Voyage data recorder and the challenges in a later round of questions, but I do want to just ask generally, did you find that the pilots and the crew of the Dali communicated effectively during the emergency?
We do, Member Chapman, yes.
And I think Member Graham's questions covered this. You found that the crew took appropriate action throughout the emergency, given the circumstances that were handed to them. Now, again, we get back to the question of whether the flushing pump should have been used, but at least in terms of the circumstances that they were faced with during the emergency, their actions were appropriate.
Given the circumstances and the information that they had at hand, yes.
And the chair covered this in some of her questions. Dali's crew was properly qualified.
That's correct, and we confirmed that with the flag state. They were also a party to our investigation, the Maritime and Port Authority of Singapore, and they confirmed that they would consider it fully manned and qualified.
And what entity or entities set crew standards? Is that the International Maritime Organization or the flag state, or is it a combination of both?
There is guidance from the International Maritime Organization, but the flag state uses that to require manning and staffing on a ship.
And about how long we may have covered this already, but I'll ask again. About how long had most of the crew been working on the ship prior to the accident?
Most of them, I believe, had been on board since October or November. They got on in Colombo in Sri Lanka. So 6 or 7 months.
Okay. And is sailing with a relatively new crew common in international shipping?
It is, because the operating companies use manning agencies, and they'll find crew from these agencies and they'll put minimum requirements, perhaps for a chief engineer who has experience on this type of ship. But yes, it's common for them to move around. And
a ship like this would be essentially in continuous operation, correct?
That's correct.
And so you would need to change out the crew periodically. It's not realistic to think that you'd have the same crew on board continuously.
Yes, sir.
Chair, thank you. I think that's all the questions I have in this round.
Thank you. I don't have any more questions in this round. Member Graham.
Just real quick, I want to just make sure I get this right, that before leaving or getting underway, there's a briefing between the master and the pilot before they get underway. Is that correct?
That's correct, Member Graham.
And is there a pilot card involved also?
There is.
Can you tell us what's on a pilot card and what the exchange would be like in this case?
So the pilot card will describe the ship's general ship handling characteristics, so stopping distance, turning diagrams, or turning radius, those kinds of things. And if there is any anomalies that need to be brought up, the captain will do that during their exchange.
And I believe the team has already said that what had happened the night before with the blackouts, they don't feel was necessary to point that out to the pilot?
That's correct.
Okay. That's all I have. Thank you.
You don't have any more? Okay, thanks. We are going to move on. Does staff need a break or continue on? Break?
We're good, Chair, if you want to.
Okay, great. So we're going to move on to the third round, which is bridge vulnerability and highway worker safety. We will start, we'll start with Member Graham.
Okay, no pressure. I'm going to go back briefly to what I started with in round one about vulnerabilities and the report that one of our specialists had done on the vessel sizes. And just this report is really thorough. and it's a robust discussion of threat that larger vessels pose to our port infrastructure. And as we've discussed previously, and again, I want to thank staff for including this in the report. I think it's important, and we need to take these threats seriously. To that end, I want to talk briefly about the Coast Guard's Ports and Waterways Safety Board of Inquiry that was convened May 15, 2024. Can you tell us more about what this Board of Inquiry is, what the Coast Guard's Board of Inquiry entails, and why the Coast Guard said they initiated this one in particular?
Member Graham, this Board of Inquiry was chartered to look at port vulnerabilities around the nation. They specifically excluded Baltimore because of our ongoing investigation, but they looked at there was 10, and they added 1, so 11 ports. They evaluated their existing risk assessment tools and legislative authorities and made recommendations to that effect. The report, I understand, is still in draft form. We haven't seen it.
Okay. How often do they convene Board of Inquiries?
It's very rare. It's been several decades.
Okay. And what is their product? What do they produce from a Board of Inquiry?
Our understanding, this specific Board of Inquiry is trying to develop a risk assessment tool for the local captain of the port, the Coast Guard captain of the port, so that they can evaluate the risk given everything from sizes to weather to infrastructure.
And that would be what, recommendations that they would come out of this?
I believe they're developing a tool to use, a risk assessment tool. And if there's legislative authorities they need to do that, then that would be a recommendation.
Okay. Do we know when that might be published by chance?
I do not know, no.
Did not know. Okay. Do you believe that it's critical for all ports nationwide, not just the 10 that were studied for this Board of Inquiry, to conduct comprehensive risk assessments for the threat that larger vessels pose to their infrastructure?
Yes, Member Graham. There is actually 11. They added 1 in the process. There's 11 ports they looked at. But the tools that they develop can be applied to any port.
That's great. I would hope every other port that's not part of this inquiry would look at this and assess the risk of their own port and infrastructure, because we can see we're already aware of quite a few that we put out our urgent safety recommendations on. So thank you.
Member Chapman.
Thank you, Chair. The staff presentation explained that the FrancisScottKeyBridge predated current requirements for bridge protection systems. The bridge opened, I believe, in 1977. Is that correct? So it was designed, I think I'm correct on this as well, that it was designed according to the 1969 AASHTO specifications for highway bridges. Am I right about that?
That's correct.
I understand then that the guide specifications changed because of the, I believe it was the 1980 Sunshine Skyway Bridge collapse. That bridge collapsed after being struck by a ship. And then I believe they've been changed again since, in 2009, I think. Do I have all that right?
I'll defer to Mr. Parent on that.
Yes, Member Chapman, that's correct.
Okay. And is it the 2009 AASHTO guide specifications that urge certain bridge owners to conduct the Method 2 risk analysis?
Member Chapman, that was also in the 1991 guide specs as well. The 2009 guide specs added the protection factor.
Okay, all right. So the encouragement to conduct the risk analysis dates to 1991.
That is correct.
There are 3 AASHTO methods for conducting a vulnerability assessment. What are the conditions that AASHTO says trigger the need for the Method 2 risk analysis?
Any bridges over navigable waterways with barge or ship traffic.
And built before 1991, is that right?
Correct.
What factors, just to give us a general idea, you don't have to list them all, but what factors does the Method 2 vulnerability assessment use in its calculation?
Sure. It looks at the number of transits under the bridge on an annual basis. It looks at the protection factor, whether it exists or not on the bridge. It looks at the geometric probability of the bridge. In other words, the distance between the spans and the probability that one of those, the piers, and if one of those piers would be struck by an aberrant vessel. And it looks at the probability that a vessel would go astray from its course.
Thank you. Now, when a bridge falls below AASHTO's risk threshold, what measures does or should a bridge owner take to mitigate the risk?
I'm sorry, did you say below the threshold?
Below the threshold. I'm sorry, if it falls above the risk threshold, what are the mitigation measures that should be taken by a bridge owner?
So there would be any countermeasure that would affect any number of those variables that I just described. That could be installing pier protection to protect the piers. Another countermeasure could be using tug escorts to kind of reduce the probability of aberrancy, strengthening the piers against impact, which is why in our urgent recommendation we had the interdisciplinary team that was developed in order to answer some of those questions and give guidance to the bridge owners.
And the likelihood is it's going to be a combination of those measures. It's not going to be any one thing, correct?
It depends. If you could fully protect a pier with dolphin structures, then that would be the single thing that would be implemented and would reduce the risk.
Okay. All right. The Maryland Department of Transportation did not do a vulnerability assessment. Do we know why that review was not conducted?
We do not.
Chair, I have some additional questions in this area. I'm going to hold them because it might take a little bit. Thank you.
Yep. So on the 1991 and 2009 AASHTO guidance, did the state of Maryland participate in the committee developing that guidance and the update?
Yes, they were part of the committee that developed those standards.
Oh, sorry, Mr. Parent. Good to see you back there. I'm so used to talking to everybody up front here. Thank you. They were part of that committee. What is the Baltimore Harbor Safety and Coordination Committee?
That was a committee that was formed in the 80s. It's essentially to address matters related to the efficiency and the safety of marine transportation systems.
And still going?
Yes.
Okay. And did the committee, is Maryland part of that or MDTA part of that committee?
They are.
Had the Baltimore Harbor Safety and Coordination Committee ever raised concerns about the vulnerability of the Key Bridge?
Yes, in 2006, an MDTA representative had mentioned that the pier protection was inadequate.
Was any meaningful action taken?
No.
No. MDTA states in their party submission the following: the increased risk to bridges posed by vessel strikes does not come from any deterioration of existing infrastructure. The bridges are strong and resilient as ever. Rather, the increased risk comes directly from the ever-increasing size of commercial vessels. The reason why we look at bridges is because we look at everything that could have prevented a tragedy, which was the tragic death of several highway workers on the bridge. And the need to constantly evaluate what sort of, as a state, what sort of vessels are transiting underneath your bridges and act accordingly. In fact, when I was there on scene, I noted, and I'm sure you all did too, that it seemed that the fender system and protection in place from a utility pole next to the Dali was more sufficient than what existed around the piers of the bridge. It was pretty extensive, probably because it was constructed under newer regulations at the time. What was the force that the Dali hit Pier 17?
Sure.
Anyone? Mr. Walsh? I can't hear you. Hit the little button. Okay, can you borrow somebody else's mic?
Chairwoman, it was over 5 times, it was nearly 5 times greater than the structural capacity of the pier.
Dan, do you want to add anything? By any means? It was 7 times greater than the structural capacity. Was it 5 or 7? I don't remember. Okay, you just yell it at this point. I'll repeat it. Okay, I'm hearing 3 different answers here. I got a writing on 7, I've got 5 from Scott, and 4 from Dr. Poland.
They calculate it based on AASHTO's estimate as being over 4 times what the capacity was for the pier.
Okay, and what were 4 times?
Over 4 times. It was nearly 5 times. That's what Mr. Parent was saying. It was nearly 5 times. So it was very close to 5 times above what the lateral capacity of the pier was.
Thank you. And with that, when we have investigated other bridge collapses, Sunshine Skyway Bridge, a couple others that we mentioned in the report, one in Texas, one in Oklahoma, what happened after Sunshine Skyway? What was the new design? How did that compare to the previous design before that collapse?
So the new design consisted of islands around the pier, as well as an array of dolphins of 60 foot in diameter.
Yeah, I mean, because you want to take every precaution to ensure the safety of those transiting, or being transported or driving over the bridge, right? You have a responsibility as well, is my point. I have additional questions on this, but Member Graham, I've run out of time.
Thank you, Chair. The AASHTO method 2, what variables go into that calculation?
So you have the number of transits, you have the probability of aberrancy, you have the geometric probability, and then you have the protection factor.
So if you had...
I'm sorry, there's one more, probability of collapse.
Okay, probability of collapse. So if you had, say, just one vessel pass under a bridge twice, going in and out in a year, would it be safe to say that that calculation would probably put that under the threshold?
Well, you really can't calculate annual frequency of collapse just based on that variable of transits. However, given the number of 2, that's a fair statement to say that it probably would be below.
So would it be fair to say, would it be fair to say just because you drop below the threshold that you're completely safe from a large ship striking a bridge and taking it down?
No.
No, because what this does, the calculation simply helps the bridge owner identify if additional mitigation strategies are necessary. Is that correct?
That's correct. It just provides them with a number to evaluate their vulnerability.
Great. Thank you for that. I want to switch to law enforcement in the construction zone the night of the striking of the bridge. And I want to say, I know we've already talked about it, but having the presence of law enforcement already there made a huge difference in this case, and I know we've already stated that. They clearly play a critical role in bridge safety, but I want to discuss exactly what that role is. Can you give a brief overview of what the American National Standards Institute's Standard A10 Work Zone Safety for Roadway Construction is, and what does it entail?
Sure, it's a standard really geared toward keeping workers safe on the highways.
Okay. And who uses this document, and when would they use it?
Yeah, so highway workers, construction companies, federal agencies, regulatory agencies, and it's typically used during the pre-planning and site-specific traffic control plans.
Okay, is this just for construction, or is this also for maintenance?
Maintenance as well.
Maintenance as well, so repairing potholes?
Yes.
Okay. I just want to be clear, this is not a regulatory requirement, is that correct?
That is correct, however, it has been largely adopted by the stakeholders.
Okay. So it's a standard practice or guidance for the industry then? Okay. We know how important pre-job briefings and planning is across all modes of transportation, and I continue to believe it is one of the most effective ways to mitigate risk because it allows real-time discussions of current conditions and measures that may need to be taken to address new or changing conditions. Currently, the pre-job planning outlined by the ANSI Standard A10 requires method statements and a job hazard analysis to be conducted before work begins. What are the required elements of this pre-job hazard analysis according to the standard?
Those requirements include safety issues and controls, materials and logistics, equipment, staffing requirements, traffic control plans, and lighting.
And can you share where the team believes this standard falls short currently?
Currently, there is no standard regarding providing emergency communication to workers in the case of some type of disaster that may occur, which is why we have a recommendation to ANSI.
Great. And tying things back to the presence of law enforcement, do you think having a pre-job discussion of whether law enforcement should be present for traffic calming, as was the case this night, or any other reason would be beneficial to road workers performing construction on bridges over navigable waters?
Absolutely. The timeliness of the law enforcement officers on that bridge to shut down that traffic saved lives. Just their mere presence also keeps workers safe in that, their visual presence may slow drivers as they pass through a construction zone.
Do all states do that?
I don't know if all states do that.
Yeah. I mean, I've seen them in construction zones on just highways, and a lot of states will have state police and stuff at the beginning or the end. But I don't see that in every state when I travel around, which is unfortunate. But I definitely agree. If we didn't have them in place that night, we could be talking about even more fatalities, unfortunately. So thank you.
Member Chapman.
Thank you, Chair. In our urgent recommendation report from March, the team identified 30 bridge owners with 68 total bridges built before 1991 that had not recently performed a vulnerability assessment and did not know their probability of collapse from a vessel strike. Have all those bridge owners responded to our urgent recommendations?
We heard from 27 respondents covering all those bridges.
Okay, so the owners of all 30 bridges have responded.
That's correct.
And they've responded, I believe the staff presentation indicated they'd responded positively.
Correct.
And have any indicated that they will measure the vulnerability of their bridges and take steps to mitigate risk if needed? In other words, are they taking the steps that are appropriate with regard to first identifying that risk and then, maybe more important, mitigating that risk?
Member Chapman, we've gotten response from numerous bridge owners. Some of them have reported that they've done the vulnerability assessment calculation and are below the AASHTO threshold.
All right.
Others have reported that they have performed the calculation and are above the threshold and are now working to implement short-term and long-term countermeasures to reduce the risk of their bridge. There are still other bridge owners that are still in the process. Some had to hire consultants to assist them with this calculation. And of course, Ms. Baldwin is available if you want to know the specific numbers of
Sure.
each in that category.
Yeah, thank you. That's helpful. Just to know that we're moving in the right direction. There are, and they've been discussed, there are numerous mitigations available and appropriate. There has been some discussion, though, even just sort of anecdotally in some of my wanderings and musings on this issue, about the use of tugs to guide large vessels under bridges. And I know that that's sometimes an important mitigation measure, but it's, can you comment, is that something that's always available, and is it always appropriate as a mitigation?
It's not always available or feasible or appropriate. Certainly, escort tugs have been used successfully in ports around the country. Staff doesn't feel that we're in a position to recommend one mitigation, specifically tugs, over another one.
Yeah, and I, with regard to tugs, it's not like there's an unlimited supply of tugs, so that's one issue, is just whether they're available depending on the port.
That's correct.
But also, it has to do with the speed of the ships traveling, because the speed of the ship they're escorting may be too much for the tug to keep up, correct?
Yes, there are speed restrictions when you're escorting a tug under tether. There's also geometry issues, so we wouldn't want to put a tug in the front of the ship in this case, especially at this speed.
Okay, thank you. Chair, that's all I have in this area.
Thank you. In accordance with National Bridge Inspection Standards, the Key Bridge and its pier protection systems were subject to regular safety inspections. Mr. Parent, what do these inspections look for?
Essentially, they're looking for structural deficiencies that may affect the safety of the traffic on the bridge, and to identify any new changes to the previous inspection.
And Maryland was in compliance with bridge inspect. There was nothing structurally wrong with the bridge. What was the rating on them?
Satisfactory.
Satisfactory. Does the inspection look at the probability of collapse from a vessel strike?
No, it does not.
No, it does not. Was Maryland aware that the Blue Nagoya had hit Pier 17 in 1980?
Yes.
Yes. Okay. And what was the difference between Blue Nagoya in 1980 and the Dali?
Well, the biggest factor would be the size. The Dali is much bigger, much heavier, wider and longer. Will provide a lot more force to the pier than the Blue Nagoya.
Yeah, and you know, I think that goes back to using some of your data and past incidents to inform some safety decisions going forward. Regarding what Member Chapman had asked about recommendations, Ms. Baldwin, can you talk about, out of all the ones that we issued, how many of the bridge owners are still are going to do the calculation, how many have done them, and how many have indicated that they are above the threshold, which once again doesn't mean it would survive collapse, but you know, how many have not have indicated they are above the threshold?
Yes, thank you, Chair. To date, we've gotten responses from all of the recipients. 14 of those recipients, which accounts for 33 of the 68 bridges, are still in the process of conducting the calculations, whether independently on their own or through a consultant or contract. 13 of the recipients, which accounts for 35 of the bridges, so about half, have completed the calculation. 13 of those bridges have been found to be under the threshold, and those calculations are complete. For 6 of the recipients, which is 22 bridges total, about 13 of their bridges were found to be over the threshold, and they're working on risk reduction calculations at this time.
Can you provide which bridges?
I don't have that at the ready right now, but I can in another round.
Great, thank you. That I would like to get that, so on the next round I will ask that question. I will turn to Member Graham.
Thank you, Chair. I just got a couple of questions about the National Bridge Inspection Standards. So it's pretty much just a structural inspection of the bridge itself, is that correct?
That's correct.
When was the last one done on the Key Bridge? Do you know?
That was 2024.
2024, and the results, any significant results out of that on the bridge?
No, just like the previous inspections, satisfactory.
And so this inspection does not evaluate the protection systems around the bridge, like the dolphins and piers and barriers, is that correct?
It does consider the protection systems and whether or not they're present and functioning.
Okay, but not if they're effective. Would that be correct?
Correct.
And this inspection is, who oversees this? Is Federal Highway Administration?
Yes.
Okay. Do we know if they have any plans on changing their inspection program for vulnerabilities?
Staff is not aware of any proposed changes.
Okay. I think that's all I have in this section. Thank you, Chair.
Thank you. Member Chapman.
No further questions, Chair.
Okay, I would like staff, while we give Ms. Baldwin some time, I want to go back to the force of the Dali when it hit Pier 17 relative to the pier's capacity. And Mr. Parent, you had stated that the impact force of the Dali at the time of contact was over 4 times the capacity of the pier. What is impact force? And in plain language, what does that mean structurally?
Thank you for the question, Chairman.
Working microphone.
Yes, the force of the Dali, the magnitude of the force was approximately 4 times greater than the capacity of the pier. And so what that would mean is that there's different variations in terms of calculating that force. It would be based on speed and deadweight tonnage of the Dali itself.
And so in plain language, structurally, that means the bridge piers were not strong enough to withstand an impact from the Dali.
That's correct.
Okay, thank you. Have I given you enough time, Ms. Baldwin? You need additional time. I can keep going. Let's talk about the dolphins, very tiny. So these dolphins, what are the purpose of dolphins? Can you talk about the size of the dolphins that were there?
Absolutely. Dolphins are sheet pile rings that extend down to the floor of the channel. In this case, it was filled with tremmy concrete, and the purpose of the dolphins is to redirect a vessel or puncture a hole in the bow of the vessel so that it doesn't strike the pier. The dolphins at the FrancisScottKeyBridge were 28-foot diameter at the cap, and below the cap, they were 25 feet diameter down to the bottom of the channel. In comparison to the Sunshine Skyway Bridge, those are 60-foot diameter dolphins, and the Delaware Memorial Bridge has 80-foot diameter dolphins.
Does the placement of dolphins also matter?
Yes, it does. Yes, it does, Chairwoman Hamady. For instance, the Delaware Memorial Bridge, they're placed very close to the pier itself, rendering the annual frequency of collapse to 0. So if you place them correctly, they will protect the pier itself.
But there's a significant difference between the size of these dolphins and the size of the dolphins after the Sunshine Skyway Bridge collapse and redesign, and the size of the dolphins in Delaware, correct?
That's correct.
Can you talk a little bit about the size difference?
Sure. Yeah, in terms of, again, the FrancisScottKeyBridge were the 25-foot diameter dolphins. They were not compatible in order to take a size of the Dali. They were woefully inadequate. The 80-foot diameter dolphins in the Delaware Memorial Bridge, depending on looking at the different aspects of the vessel itself, they will puncture a bow in the vessel before striking a pier.
And did the Dali even hit these dolphins at all? Any dolphin at all?
They did not.
Right. Yeah. So placement and size here make a big difference.
That's correct.
Ms. Baldwin.
Yes, thank you, Chair, and thank you for the extra time. So the bridges that we have had reports that are over the threshold are the Walt Whitman and Betsy Ross Bridge in the New Jersey Turnpike, the Seaway International Bridge, Detroit Avenue and Carnegie Avenue bridges in Ohio, the Vincent Cassiano Newark Bay Bridge, the Huey P. Long, Greater New Orleans, Crescent City Connection, Gramercy, and Sunshine Bridges in Louisiana, and both spans of the Chesapeake Bay Bridge.
Great. Thank you very much for that. I appreciate that. Any more questions in this area? Yep. Okay. So we are going to go, we're going to go to round 4, which is voyage data recorders and safety management. Oh, Member Graham.
Okay. I don't know if you guys need to do a little swap out there.
We do. I'd like to invite and thank Dr. Civilian from our Office of Aviation Safety.
Great, thank you. I'll go ahead and start with the marine side of this. Can you guys give me an overview of how safety management systems, also known as SMS, work in the marine industry? Kind of what is the definition of SMS for marine, and what are the requirement elements, and who mandates and oversees it, if you could?
So the most common standard is the International Safety Management Code, which is published by the International Maritime Organization. That applies to all vessels on international voyages over 500 tons or carrying 12 or more passengers. That code, there's 12 functional elements. It requires safety and environmental policy, and then it also requires you to identify key shipboard operations which need to then develop procedures to follow in order to, and the goal is to prevent or to promote safety and environmental protection along with regulatory compliance.
Okay, thank you. And is SMS done kind of vessel by vessel, or is it done company-wide?
The code applies to the operating companies, and also each vessel has its own certificate.
Would you say would it be fair to say that marine SMS is heavily focused on compliance with policies and procedures?
That would be fair to say. There's 2 of the elements are policy and 1 for procedures, but the other elements revolve around auditing and investigating nonconformities with those procedures.
Auditing, okay. As part of our investigation, did we find that Synergy's SMS was in compliance with the IMO regulation?
It was in compliance. They had a valid safety management certificate, and the Synergy as a company had a valid document of compliance. The several audits, there was only a few nonconformities in the past 5 years.
Did we find during the investigation that Synergy went above and beyond the IMO code for this?
That's fair to say. Some of that may be attributed to what they call an integrated management system, because it also included ISO 14001 environmental management, information security management, energy management, and there's a couple, but because of that, their SMS had a lot more in it than a system that only had SMS.
So they went above the IMO regulation, you believe?
That's correct.
Okay. I'd like to welcome Dr. Civilian in here. He's a specialist in safety management systems in aviation, and since International Maritime Organization is a United Nations entity setting standards for marine industry internationally, can you provide a similar overview of how safety management systems is defined, the required elements and oversight structure as outlined by the International Civil Aviation Organization, or ICAO?
Absolutely. The International Civil Aviation Organization, or ICAO, establishes the protocol, if you will, for SMS. And the SMS components, there are 4 components for SMS, and that is safety policy, safety risk management, safety promotion, and safety assurance. And all of those components are required when you are developing and integrating an SMS. An important part of that, in terms of what ICAO discusses, is having an accountable executive to sort of lead that way for the organization to implement the SMS.
Okay, thank you. Definition, so it's more or less, it's company or organization-wide SMS is in aviation. Is that correct?
That is true, and it's a top-down process of looking at risks and the mitigation of those risks throughout the organization.
So it's risk-based?
Yes.
Predictive and proactive?
Correct.
Okay. I think I'll leave it at that. I don't have much time. I'll come back next round.
Member Chapman.
Thank you, Chair. Mr. Payne, a couple of questions about video, I'm sorry, voyage data recorders. Your presentation was very helpful, and I do want to just ask you to revisit a couple of the points that you covered in your presentation. Why were you unable to download the full VDR data set while on the ship?
I think this case was unique in the sense that when we first arrived on scene, we had begun hearing rumors that there were a blackout on the previous day. So then it became required not just to download the incident itself, but the previous 24 hours. If we think like an investigator, we know that the voyage data recorder was required to have 30 days, at least 30 days of data. It then became interested to attempt to download all 30 days of that information. And the requirements do not specifically say that an investigator needs to be able to do that when communicating with the VDR, even though it is capable of storing that much data. So simply stated, the VDR continued to fail that download every time we tried it, which resulted in us removing the VDR and bringing it to the manufacturer's facility.
And then at that point, what issues did you and the NTSB team encounter after recovering the Dali's VDR for analysis?
Sure, there's quite a number of things that are not just unique to this particular brand of VDR, but are prevalent throughout the industry and not addressed by the standards. But I talked about the isolation of microphone audio. Quick example, there's multiple microphones on the bridge. The system requirements state that they can mix two of these together in a way that can't be separated later. That's a legacy requirement from the early 2000s, late 90s, when storage space was at a premium. They designed the recorders this way to be functional and cheaper because memory space was expensive. We're going into other things like exporting the data because the software is not robust enough to perform a thorough and detailed analysis. We must export the data. This particular VDR exports the audio, for example, in 1-minute segments. So if we wanted to download 12 minutes of audio, I believe, or 12 hours of audio, I think there were 6 channels. That's 12 times 6 times however many minutes in the hour of that time, resulting in thousands of files, right? I think it's important to keep coming back to saying that the standards allow this, and it's not just a specific manufacturer of the VDR, but those were some of the challenges we faced, and it's prevalent throughout the marine VDR investigative niche.
So with those in mind as the challenges and the deficiencies, what are the improvements you'd like to see?
Yeah, I think we are asking for the standard specifically on the IEC side, which sets the specific technical standards to address common scenarios that would be encountered with how an investigator uses the information, as well as someone who would like to be proactive in their SMS. So, for example, we could go to any ship in Baltimore and download a VDR of a ship that just docked, play back that data and see, oh, okay, the ship docked successfully. We can hear the pilots giving orders. It's not until you peel one more layer of that onion that you start to run into these problems like timing errors, exporting problems, the inability to make a simple graph of the data. Our recommendations seek to have the technical committee address these types of things that would enable people that want to use the VDR for safety issues to address these things in a more understandable way.
Thank you. Very helpful. Chair, I have a couple more questions in this area. I'm going to save them.
Great. And just why is it, just for others, why is it so important to have the data for the NTSB, for regulators, for operators?
Sure. I think we can use it, the industry could use it to be proactive. I look at the experience that I have with downloading these things, and my team, including Matt Yandrick, who did a lot of work on this VDR, we are used to the common problems. If you're just a casual user trying to use the information for safety, you're going to have a hard time to accomplish that, the way the standards are written.
Thank you very much. Dr. Civilian, just picking up on where Member Graham left off, you mentioned the ICAO standards for SMS and the various pillars of SMS. Based on your work with the Office of Marine Safety, what aspects of SMS does the International Maritime Organization focus on?
IMO focused primarily on safety policy and regulatory compliance. There were 6 functional requirements, and if you look at those functional requirements, it's sort of an umbrella around safety policy and regulatory compliance.
Yeah, it does seem more focused on compliance with policy than all the other components of SMS. And could the International Maritime Organization benefit from updating its SMS framework to incorporate the other pillars of assurance, performance, and promotion, all of which are familiar to aviation?
Absolutely, because it's important to have a systematic approach to safety. And when you have all 4 of those components, you now have a formal method of managing safety.
My understanding is the IMO is in the process of looking at this again, just already, not related to this.
That's correct, Chairman. Earlier this year, the IMO tasked 2 of their subcommittees to start the process of updating the implementation guidelines, and then if necessary, they'll move on to the code.
Okay, great. Member Graham.
Thank you, Chair. Mr. Payne, if configured correctly, Void's data recorder, could it be used like a flight data recorder in aviation?
It could be accessible in a way that a flight data recorder is. In terms of the number of parameters that it would record, it would not be similar, but the ability exists to use it in that way, yes.
So companies could use it, not unlike airlines and other operators in aviation to...
Yes, certainly. They could gain a great amount of operational insight if they had the ability to communicate with the VDR and review it regularly.
With risk management and safety assurance, 2 pillars of a good SMS, which leads me to, as we've heard from both our marine and aviation teams, safety management systems is handled differently in both industries. As most people know, I have long been a proponent of SMS in my career before coming to the board, here at the board, and across all modes of transportation. I've seen firsthand how an SMS is the most effective way to either eliminate or mitigate risk while maximizing your resources. Given my involvement with and oversight of SMS throughout my career, I am concerned that the maritime industry's definition of SMS as it exists today and outlined in the IMS code has concerning gaps when it comes to fulfilling the 4 components or pillars of a comprehensive SMS. I recognize, and I want to thank our staff for helping educate me on this, that there are certain fundamental differences between marine and other modes of transportation that need to be accounted for when it comes to SMS. Understanding those differences, however, it is clear the current SMS standard set by IMO is immature and leaves gaps in SMS or in safety management. The ISM code's definition of SMS itself is incomplete as it focuses mostly on compliance and implementation of policy rather than taking a systematic, risk-based approach. There are certain aspects of the existing IMS code that address some of the 4 pillars or 4 components required for a comprehensive SMS. As noted in this report, safety policy is addressed through many of the code's 6 functional requirements of SMS. There are also elements of safety promotion that are addressed in the code, such as requiring detailed communication and training requirements associated with an SMS. However, current maritime regulations are woefully insufficient or in some cases silent on certain elements of an SMS. As this final report notes, safety risk management requires hazard identification by both reactive and proactive methods, as well as safety risk analysis, assessment, and control using processes that include predictive methods. The existing IMS code's handling of risk management is entirely reactive. In order to fulfill this component, the code needs to incorporate proactive hazard identification and predictive analysis, assessment, and control, which can be achieved through a much more robust data analysis than exists today in the industry. Similarly, the safety assurance pillar of SMS evaluates the continued effectiveness of implemented risk control strategies and supports the identification of new hazards through data collection and analysis. Safety assurance includes management of change, which assesses safety implications of changing before implementation and manages safety risks that may arise from these changes. Management of change is not a requirement of marine SMS under the IMS code, but it is critical to ensuring any changes in an operation, such as varying staffing levels, engineering modifications, or changes in the type of fuel used, do not compromise safety. The marine industry has the foundation for a holistic SMS, but they need to build upon the foundation and advance SMS to meet the comprehensive, systematic approach that we have seen applied in the other modes of transportation. Many of these issues we have discussed today as part of this accident could have been identified, addressed, and either mitigated or eliminated if a comprehensive SMS was in place. I want to thank our investigative team for working with me on this issue, and Dr. Civilian for stepping in late in the game to help out. And I know we can improve maritime safety by advocating for the incorporation of all 4 components of SMS into the IMS code. And I look forward to working with our team, the Coast Guard, IMO, and any other organizations in the maritime industry in moving the ball forward on incorporating a fully mature safety management system. Thank you.
Thanks. Members are just reminded that you have an opportunity to do a closing statement before I do mine. Member Chapman.
Thank you, Chair. Just a couple of additional questions in this area. And again, for you, Mr. Payne, on VDRs. In your presentation, you included a helpful visual on the VDR regulatory framework. Can you just repeat for us, what's the relative role of the International Maritime Organization versus the International Electrotechnical Commission?
Sure, it's slide 78. I'm not sure it's necessary. I'll just start speaking to it. The IMO generally sets overall performance characteristics for VDRs. In other words, it lists the parameters, for example, that the VDR is required to record, which is not very much, I might add. The Electrotechnical Commission, on the other hand, once it is determined on the IMO side how the VDR should generally behave and what it should record, if you are a company that sets out to build one, you would then reference the IEC's technical specifications. For example, what kind of microphone performance you would need, what kind of screenshots it should take of the radar screen, stuff like that. So these two kind of work in conjunction to set an overall standard.
And as the graphic illustrates, the U.S. Coast Guard is the U.S. representative to the IMO, and the American National Standards Institute is the representative to the IEC, correct?
That's correct.
The draft report states that IMO standards do not require that a VDR record important communications between the bridge and the engine room. In our El Faro investigation several years ago, we issued a recommendation to the Coast Guard that included proposing to the IMO that it should, and I'm going to quote, that IMO should assess voyage data recorder problems, including not capturing both sides of internal phone calls on the bridge electric telephone. Mr. Payne, did the Coast Guard respond to our recommendation?
Yes, they did. Ultimately, that recommendation, I think, was determined to have an unacceptable response. The IMO did not implement any changes. Specifically for that recommendation, although it did contain that portion of the language you stated, it did also contain other elements we were asking for that I think overall were difficult to bring to the table at IMO as one, if that makes sense. But ultimately, the response was it was not acceptable, and if I've said that incorrectly, maybe Brandy, Ms. Baldwin can correct me.
So the bottom line here is that we're still in a situation where we're not recording both sides of internal phone calls, and that was a challenge in this investigation too, correct?
Yeah, I'm bringing this forward in a way from the El Faro. In this particular investigation, there were at least 3 phone calls to the engine room from the bridge, all by quick phone calls. It was the nature of the casualty, happened very quickly. And there was one immediately post-accident in which the master of the Dali asked what happened to the engine room. I think holistically, the marine industry, we have bridge officers and we have engineers. The engineers are as critical as the bridge team in operating a ship. And when we have an accident, that communications line is often critical if it involves a machinery problem or equipment malfunction propulsion issue. What we have seen, and not just those 2 investigations, are one-sided recording of the conversation. So in the El Faro, we got the captain saying, yes, okay, got it, that's bad, stuff like that. But we're not capturing the engineers explaining the problem to them. I don't necessarily think that's what happened in the Dali, but the master did call the engine room to ask for 3 status updates, as well as the second officer.
Yeah, and having both sides of that conversation would be helpful under any circumstances.
Yes, absolutely. It's part of the operation of the vessel.
My last question in this area, I believe you indicated in your presentation that the Dali's VDR and the playback software met both IMO and IEC standards. But was that playback software, was that useful?
No, we did not use, other than playing back the incident initially to ensure it was captured, the type of work that someone would need to do to get a good grasp of what actually happened is done by marine investigators around the world outside of this VDR software for most every brand.
So is it fair to say that this whole area needs a comprehensive look in terms of both the standards and the practices that are being used to try to capture this information?
Yeah, I'm thankful to have the opportunity to bring this up in such a public forum for such a major accident. I don't believe it's been spoken about in other marine investigation reports, specifically calling out the software and bringing to light that we use alternate software to conduct these investigations. That's a reason we export the data in the first place.
Thank you. Thanks for sharing the concerns. Chair, I don't have any other questions in this area.
Do you have any other questions? Okay. So we'll move to our final round of questions on any other safety issues that we did not discuss or anything we want to discuss in addition. I'm going to start with Ms. Adler. I often say that the board meeting or closing out the final investigation with a final investigative report is really just the start of our work because it is up to us to work towards implementation of our safety recommendations, which are aimed at preventing this from happening again. So, Ms. Adler, can you talk about what we do after today?
Sure. Thank you for the question, Chair. So after today, and then Ms. Baldwin behind me leads the team of safety recommendation specialists who will continue to work diligently to close these recommendations, with partnership from the modal offices and highway safety and marine safety. So as we discussed earlier, we have a number of urgent recommendations, for the 14 recipients that are currently conducting the vulnerability assessments. The team will get updates from them to make sure they're complying with the recommendation. And then additionally, for the 13 bridges over the risk threshold. The urgent recommendation directed these bridge owners to develop and implement comprehensive risk reduction plans. So the team will continue to monitor progress on that and bring that to the board for evaluation once we receive those updates. Now, the draft report and the team have proposed many new recommendations for consideration today, and if those are adopted, we'll meet with the recipients to ensure that they understand the recommendations and what we're expecting from them, and then we'll evaluate any actions that they take. And as I said, the safety recommendation specialists work diligently with the recommendation recipients to close these out. It's on average, we have an 80% rate of closure. The recommendations are closed acceptably. So we have a really good response from the recommendation recipients when we get it. And then additionally, if we're not getting movement in some areas, we always look to our federal partners and we look to Congress and local and state elected officials to help us out. So we have a government affairs team that also continues to work in that way.
Thank you. I think that's an excellent summary of our work after today. I did forget to ask Mr. Parent about the need for motorist warning systems. We're going to talk about a recommendation and some findings and what types are available, and the need for updating guidance.
Sure. So the guidance is from 1983. It's an FHWA advisory, technical advisory. We looked at the Queen Isabella Causeway motorist warning system that was installed after the repair of that. It involves fiber optic cable that when severed, it activates the motorist warning system, which includes flashing red lights, which could be beneficial for workers on bridges as well as a visual cue to evacuate the bridge, not just trying to hear something if they're doing construction. And we think that motorist warning system will definitely complement the bridge. Particularly, it can be implemented quickly in spite of some of the long-term rehabilitations or reconstructions of a bridge might undergo.
Yeah, and in this case, there was stopped traffic, but there could be other times where they're not, and it's aimed at getting all motorists off the bridge in a safe way. And not relying on a cell phone communication between an inspector and a police officer to then notify the workers. And as you mentioned, there was time that went by that could have been used for the workers to get off the bridge. So thank you for that. Member Graham. No further questions. Member Chapman. Okay. With that, I think that closes out our questions. Is staff okay if we move to the findings? Okay. All right. Mr. Curtis, will you please read the proposed findings?
Certainly, Chair. As a result of this investigation, staff proposes 24 new findings. Number 1, none of the following were factors in this accident. 1, environmental or waterway conditions. 2, vessel complement and mariner credentialing. 3, impairment of the Dali crew or pilots due to alcohol or other tested for drugs. 4, fuel quality or switchover of fuels. 5, vessel's ability to get underway after import blackouts. Or 6, the presence of non-redundant steel tension members in the KeyBridge's continuous steel through truss. Number 2, the initial March 26 low-voltage blackout was caused by wire 1 electrically disconnecting from terminal block 381 within the HV switchboard, which resulted in high-voltage breaker HR1 opening, interrupting power to step-down transformer TR1 and the LV bus. Number 3, the position of the wire label banding on the ferrule of terminal block 381's wire 1 prevented wire 1 from being fully inserted into the terminal block spring clamp gate, causing an inadequate connection and leaving wire 1 loose and vulnerable to becoming electrically disconnected. Number 4, if infrared thermal imaging had been used to inspect wire connections within the HV switchboard before the accident as part of the Dali's preventative maintenance program, the loose signal wire may have been identified. Number 5, the loss of power to the low-voltage bus led to a loss of lighting and machinery, including the main engine cooling water pump and the steering gear pumps, which resulted in a loss of propulsion and steering. Number 6, the as-built configuration of the Dali's main engine to automatically shut down due to low cooling water pressure met classifications standards at the time the vessel was constructed. However, it endangered the vessel because it prevented the main engine from being available following the initial underway blackout, thus reducing the vessel's maneuverability. Number 7, the engineering crew's initial response to restoring low-voltage LV power after the first underway blackout was timely. Number 8, the second underway blackout on March 26 and the second in-port blackout on March 25, during which both the high and low-voltage buses lost power, were caused by insufficient fuel pressure to online diesel generators, resulting from the inability of the flushing pump to automatically restart following a loss of power. Number 9, the crew's operation of the flushing pump as the service pump for online diesel generators was inappropriate because the necessary fuel pressure for diesel generator 3 and diesel generator 4 would not be automatically reestablished after a blackout per the fuel system's design. Number 10, Synergy's operational oversight was inadequate because it did not discontinue crew's ongoing use of the flushing pump as a service pump for the diesel generators aboard the Dali and at least one other vessel. Number 11, keeping the high voltage HV breakers control modes set to automatic rather than manual would not have prevented either underway blackout, but it would have shortened the duration of the initial underway blackout from 58 seconds to 10 seconds, providing more time for the crew to attempt to recover critical systems, such as propulsion, as the vessel approached the Key Bridge. Number 12, it is likely that the emergency diesel generator's failure to connect and power the emergency switchboard within 45 seconds, as required by International Maritime Organization regulations, was due to the emergency diesel generator radiator damper actuator's limit switch not indicating open in the required time due to unknown circumstances. Number 13, the actions of the pilots and the bridge team in response to the emergency were executed in a timely manner, but the vessel's loss of propulsion close to the Key Bridge rendered their actions ineffective. Number 14, the pilots, the pilot dispatchers, and the Maryland Transportation Authority's quick actions to stop bridge traffic prevented a greater loss of life from the bridge collapse. Number 15, in lieu of police officers or highway workers charged with traffic control and capable of quickly stopping traffic, a motorist warning system designed to warn and stop motorists from entering onto a bridge is a possible countermeasure that can be quickly implemented to save lives and may be a component of an effective bridge protection strategy. Number 16, owners of bridges over navigable waterways frequented by ocean-going vessels would benefit from updated guidance on motorist warning systems, including incorporation of hazard alert and sensing technologies capable of detecting errant vessels and bridge movements that would indicate a need for bridge closure and systems that would both warn and prevent motorists from entering a bridge once a threat is detected. Number 17, had the inspector and highway workers been notified of the Dali's emergency situation about the same time the Maryland Transportation Authority police officers at each end of the bridge were told to block vehicular traffic, the highway workers may have had sufficient time to drive to a portion of the bridge that did not collapse. Number 18, effective and immediate communication to evacuate the bridge during an emergency is critical to ensuring the safety of bridge workers. Number 19, While the requirements of the International Safety Management Code include some elements of a comprehensive, proactive safety management system, the code does not fully encompass all 4 critical components of safety policy, safety risk management, safety assurance, and safety promotion. Number 20, the lack of recording of parametric information by the voyage data recorder during a power loss can inhibit proactive monitoring of these data by organizations and adversely impact an accident investigation. Number 21, audio information from both sides of the Dali's electric telephone was not recorded during the accident, which prevented the National Transportation Safety Board from hearing the engine room's responses to the accident. Number 22, the monaural audio configuration of the Dali's Japan Radio Company Limited Brand JCY1900 Voyage Data Recorder System, which mixed multiple microphones into shared channels, significantly impaired the National Transportation Safety Board's ability to isolate and analyze critical bridge conversations, distinct voices, and sounds from the alarms and background noise, thereby reducing the recording's intelligibility and limiting the effectiveness of audio enhancement tools. Number 23, although the Dali's Japan Radio Company Limited Brand JCY1900 Voyage Data Recorder complied with International Maritime Organization and International Electrotechnical Commission standards, significant deficiencies in data accessibilities, audio usability, and playback software functionality revealed a critical disconnect between published technical standards and practical investigation and organizational needs to identify safety issues and solutions, and for operators and regulators to ensure safety. Number 24, increasingly larger cargo vessels, such as the Dali, pose increased risks and challenges to maritime safety due to their reduced maneuverability in proximity to existing port and waterway infrastructure that was not designed to accommodate vessels of such size. Additionally, this report contains the following 3 findings previously issued by the National Transportation Safety Board in March of this year in its report titled Safeguarding Bridges from Vessel Strikes, Need for Vulnerability Assessment and Risk Reduction Strategies. Number 1, had the Maryland Transportation Authority, MDTA, conducted a vulnerability assessment of the Francis Scott Key Bridge based on recent vessel traffic as recommended by the 1991 and 2009 American Association of State Highway and Transportation Officials, AASHTO, guide specifications, the MDTA would have been aware that this critical essential bridge was above the AASHTO threshold of risk for catastrophic collapse from a vessel collision when the Dali collision occurred. Number 2, had the Maryland Transportation Authority, MDTA, conducted a vulnerability assessment of the Francis Scott Key Bridge using the American Association of State Highway and Transportation Officials Method 2 vulnerability assessment calculation, the MDTA would have had information to proactively identify strategies to reduce the risk of a collapse and loss of lives associated with a vessel collision with the bridge. And number 3, the 30 owners of 68 bridges over navigable waterways frequented by ocean-going vessels are likely unaware of their bridge's risk of catastrophic collapse from a vessel collision and the potential need to implement countermeasures to reduce the bridge's vulnerability. Chair.
Thank you, Mr. Curtis. I am aware of at least one amendment, and so I'll recognize Member Graham.
Thank you, Chair. I move to add one additional finding, and it will read as such, and I think they can put it up on the board also on the screen. The new finding I propose states, as cargo vessel designs continue to evolve with the latest available standards and technology, increased redundancy to maintain critical systems, such as the main engine and steering, can mitigate risk in restricted waters.
I'll second. and discussion. Member Graham.
Thank you. I'll cut to the chase here. I think this finding is needed to fully support our recommendation 1 about redundancy. I know the team has talked a lot about, I think, finding 5 and 6 on this that kind of leads to that, but I think we need to state in so many words the redundancy portion of this is needed, especially for these critical systems.
Member Chapman, anything?
I support the amendment. Thank you.
And staff?
Staff supports the amendment.
Great. We will go to council to tally the vote.
Thanks, Chair. Board, if in favor of adding the new finding proposed by Member Graham, say aye. If opposed, say nay. Also, for this meeting, Member Inman has provided his proxy to Member Graham. So, Member Graham, please enter Member Inman's vote when I call Member Inman by proxy. Member Graham.
Aye.
Member Chapman.
Aye.
Member Inman by proxy.
Aye.
And Chair.
Aye.
All right, Chair, all in favor.
Thank you. Other amendments to the findings? Okay, so is there a motion to adopt the findings as amended?
So moved.
Is there a second?
Second.
All right, the motion to adopt the findings as amended. We will go to a roll call vote. And again, we are voting on the new findings, not the previously issued findings that were part of the urgent recommendation report. Mr. McMurray.
Correct, Chair, including the additional finding that was just added. Board, this is a vote on adopting the findings as amended. Please say aye or nay. Member Graham?
Aye.
Member Chapman?
Aye.
Member Inman by proxy?
Aye.
And Chair?
Aye.
All right, Chair, all in favor.
Thank you. Mr. Curtis, will you please read the proposed probable cause?
Staff proposes the following probable cause. The National Transportation Safety Board determines that the probable cause of the contact of the container ship Dali with the FrancisScottKeyBridge was a loss of electrical power, blackout, due to a loose signal wire connection to a terminal block stemming from the improper installation of wire label banding, resulting in the vessel's loss of propulsion and steering close to the bridge. Contributing to the collapse of the Key Bridge and the loss of life was the lack of countermeasures to reduce the bridge's vulnerability to collapse due to impact by ocean-going vessels, which could have been implemented if a vulnerability assessment had been conducted by the Maryland Transportation Authority, as recommended by the American Association of State Highway and Transportation Officials. Also contributing to the loss of life was the lack of effective and immediate communications to notify the highway workers to evacuate the bridge. Chair.
Thank you. And Member Graham has an amendment. I'll recognize Member Graham.
Thank you, Chair. I move to amend the probable cause to add a additional contributing. This would start, I won't read the whole thing, but I'll start at the end of the first sentence where it says close to the bridge, period. I would like to add, contributing to the crew's inability to recover propulsion from the loss of electrical power was the limited time available due to the Dali's proximity to the bridge, period. And then the other contributing would start after that.
Thank you very much. Is there a second?
Second for the purpose of discussion.
Great. Recognizing Member Graham for the start of the discussion.
Thank you, Chair. With all my discussions with the team, they seem to really harp on the point that the crew's actions were as timely as they could be, and they were appropriate and also impressive considering the circumstance, but they're just, because of the proximity to the bridge, they just couldn't get everything started back up again and avoid from hitting the bridge. So I think this contributing factor states that point, which I personally believe you have told me over and over again. So I think it really fits in the probable cause. Thank you.
Member Chapman.
No discussion. I would like to hear what the staff has to say. Thank you.
Staff.
Staff concurs with the amendment.
No further discussion. Thanks.
Okay, great. We'll go to a roll call vote.
All right, this is a vote in favor of the amendment to the probable cause proposed by Member Graham. Member Graham.
Aye.
Member Chapman.
Aye.
Member Inman by proxy. Member Graham, that would be.
Aye. Sorry.
And Chair Homendy.
Aye.
All right, Chair, all in favor.
Thank you. Is there a motion to adopt the probable cause as amended?
So moved.
Second.
Great. And council, you will call the roll and tally the vote.
Yes, Board, this is a vote in favor of the probable cause as amended. Member Graham?
Aye.
Member Chapman?
Aye.
Member Inman by proxy?
Aye.
And Chair Homendy.
Aye.
All in favor, Chair.
Great. Mr. Curtis, will you please read the proposed recommendations?
Certainly, Chair. As a result of this investigation, staff proposes the following 17 new safety recommendations, 3 to the U.S. Coast Guard. Number 1, conduct and publish the results of a study that examines the availability, feasibility, and safety benefits of redundant means to ensure that large single propulsion engine cargo vessels maintain propulsion and steering when maneuvering in restricted waters. Number 2, propose to the International Maritime Organization that it revise the International Management Code for the safe operation of ships and for pollution prevention and associated guidelines to fully incorporate safety policy, safety risk management, safety assurance, and safety promotion into its safety management system requirements. Number 3, notify the International Maritime Organization, IMO, of the Voyage Data Recorder, VDR, technical issues encountered during our investigation into the contact of containership Dali with the FrancisScottKeyBridge and subsequent bridge collapse, and submit to the IMO a concrete proposal to require 1, the recording of mandatory data inputs from systems that remain powered during a blackout, 2, the recording of engine room communications to the bridge, 3, the recording of multiple bridge microphone inputs such that the audio channels can be isolated or recorded independently, and 4, performance requirements for playback software that facilitates real-world use, including enhanced criteria for exporting proprietary VDR data into open industry standard formats. One recommendation to Nippon KE Class NK. Number 4, share the circumstances of the contact of the containership Dali with the FrancisScottKeyBridge and subsequent bridge collapse with the International Association of Classification Societies and urge them to distribute report MIR-25-XX report to their members, highlighting A, the importance of avoiding placement of wire label banding such that it impedes the proper insertion of a wire in a terminal block, B, the benefits of using infrared thermal imaging as part of a preventive maintenance program for routine monitoring of electrical components to detect inadequate signal wire connections, C, the potential risk that partially open radiator dampers can pose to emergency generator starting, and D, the need for members to review their rules on acceptable emergency generator start design. One recommendation to the American National Standards Institute. Number 5, propose to the International Electrotechnical Commission Technical Committee 80 to revise IEC 61996-1 Edition 2 to require 1, the recording of mandatory data inputs from systems that remain powered during a blackout, 2, the recording of engine room communications to the bridge, 3, the recording of multiple bridge microphone inputs such that the audio channels can be isolated or recorded independently, and 4, the updating of performance requirements for playback software that facilitates real-world use, including enhanced criteria for exporting proprietary voyage data recorder data into open industry standard formats. One recommendation to the American National Standards Institute Accredited Standards Committee on Safety in Construction and Demolitions Operations, A10. Number 6, revise ANSI/ASSP A10.47 work zone safety for roadway construction to include an effective and immediate means of emergency communications to alert workers performing roadway work on bridges over navigable waterways, which should consider the presence of law enforcement for traffic control. One recommendation to the Harbor Safety Committee National Steering Team, number 7. Share with harbor safety committees nationwide the circumstances of the contact of the container ship Dali with the Francis Scott Key Bridge and subsequent bridge collapse, highlighting the importance of having a procedure, including immediately available emergency contact information for pilots to initiate contact with shoreside support in an emergency requiring shoreside action to ensure timely and efficient action by first responders and port stakeholders. One recommendation to HD Hyundai Heavy Industries, number 8. Incorporate proper wire label banding installation methods into your electrical department's standard operating procedures to ensure that wire label banding installed on a wire does not impede the proper insertion of the wire into a terminal block. 5 recommendations to Synergy Marine Group Private Limited. Number 9. With Classification Society approval, implement into your preventive maintenance program and safety management system the use of infrared thermal imaging for routine monitoring of electrical components, including the means to detect inadequate signal wire connections. Number 10, identify ships you operate that are equipped with a Hyundai MAN B&W 9S90ME C9.2 engine and ensure that they are not configured to automatically shut down due to low cooling water pressure. Number 11, develop, implement, and monitor for compliance and effectiveness a safety management system policy and procedure to ensure that vessel crews are using the fuel oil service pumps as designed for the diesel generator fuel supply systems installed on board your vessels. Number 12, develop, implement, and monitor for compliance and effectiveness a safety management system policy and procedure to ensure that vessel crews are setting high voltage breakers control mode to automatic while operating unless the transformer breakers are being manually operated or maintenance is being performed. Number 13, identify ships you operate with similar arrangements to the Dali and notify crews of those vessels that partially open radiator dampers can delay or prevent the emergency diesel generator from starting automatically. One recommendation to Wago Corporation. Number 14, add a warning in your product data sheet accompanying Wago Terminal Block 281-681 model, as well as any other terminal block models or similar products that incorporate wire label banding you manufacture, to explain that improperly placed wire label banding can impede the proper insertion of a wire into a terminal block. One recommendation to the California Department of Transportation, the Golden Gate Bridge Highway and Transportation District, the U.S. Army Corps of Engineers, the Skyway Concession Company, LLC, the Louisiana Department of Transportation and Development, the Maryland Transportation Authority, the Mackinac Bridge Authority, the New Hampshire Department of Transportation, the Delaware River Port Authority, the New Jersey Turnpike Authority, the New York State Bridge Authority, the Ogdensburg Bridge and Port Authority, the Seaway International Bridge Corporation, the Thousand Islands Bridge Authority, the Ohio Department of Transportation, the Oregon Department of Transportation, the Rhode Island Turnpike and Bridge Authority, the Texas Department of Transportation, the Washington State Department of Transportation, and the Wisconsin Department of Transportation. Number 15, as part of your short-term bridge risk reduction and mitigation strategies to protect the traveling public, evaluate the need for, and if appropriate, incorporate motorist warning systems capable of activating when a threat is identified and immediately warn and stop motorists from entering onto the bridge. One recommendation to the American Association of State Highway and Transportation Officials. Number 16, update your guide specifications and commentary for vessel collision design of highway bridges to include guidance in the selection of motorist warning systems. Evaluated changes should include Federal Highway Administration research on hazard alert and sensing technologies capable of detecting errant vessels and bridge movements that would indicate a need for bridge closure and would both warn and prevent motorists from entering a bridge once a threat is detected. And one recommendation to the Federal Highway Administration, number 17. Research hazard alert and sensing technologies capable of detecting errant vessels and bridge movements that would indicate a need for bridge closure and would both warn and prevent motorists from entering a bridge once a threat is detected. Provide the results of your research to the American Association of State Highway and Transportation Officials. Additionally, this report contains the following 4 urgent safety recommendations previously issued by the National Transportation Safety Board in March of this year in its report titled Safeguarding Bridges from Vessel Strikes, Need for Vulnerability Assessment and Risk Reduction Strategies. One recommendation to the Federal Highway Administration. Number 1, recommendation H-25-1, in coordination with the U.S. Coast Guard and U.S. Army Corps of Engineers, establish an interdisciplinary team, including representatives from the Federal Highway Administration, U.S. Coast Guard, and U.S. Army Corps of Engineers, and provide guidance and assistance to bridge owners on evaluating and reducing the risk of a bridge collapse from a vessel collision. One recommendation to the U.S. Coast Guard and the U.S. Army Corps of Engineers. Number 2, recommendation H-25-2, support the Federal Highway Administration in establishing an interdisciplinary team, including representatives from the Federal Highway Administration, U.S. Coast Guard, and U.S. Army Corps of Engineers, and provide guidance and assistance to bridge owners on evaluating and reducing the risk of a bridge collapse from a vessel collision. And 2 recommendations to the Bay Area Toll Authority, the California Department of Transportation, the Golden Gate Bridge Highway and Transportation District, the U.S. Army Corps of Engineers, the Florida Department of Transportation, the Georgia Department of Transportation, Skyway Concession Company, LLC, the Louisiana Department of Transportation and Development, the New Orleans Public Belt Railroad, the Maryland Transportation Authority, the Massachusetts Department of Transportation, the Mackinac Bridge Authority, the New Hampshire Department of Transportation, the Delaware River Port Authority, the New Jersey Port Turnpike Authority, Metropolitan Transportation Authority Bridges and Tunnels, the New York City Department of Transportation, the New York State Bridge Authority, the Ogdensburg Bridge and Port Authority, the Port Authority of New York and New Jersey, the Seaway International Bridge Corporation, the Thousand Islands Bridge Corporation, the Ohio Department of Transportation, the Oregon Department of Transportation, the Pennsylvania Turnpike Commission, the Rhode Island Turnpike and Bridge Authority, the Harris County Toll Road Authority, the Texas Department of Transportation, the Washington State Department of Transportation, and the Wisconsin Department of Transportation. Number 3, recommendation H-25-3. Calculate the American Association of State Highway and Transportation Officials, AASHTO, Method 2 annual frequency of collapse for the bridges identified in Appendix B of this report, for which you are responsible, and inform the National Transportation Safety Board whether the probability of collapse is above the AASHTO threshold. And number 4, recommendation H-25-4. If the calculations that you performed in response to safety recommendation H-25-3 indicate that a bridge has an annual frequency of collapse greater than the American Association of State Highway and Transportation Officials threshold, develop and implement a comprehensive risk reduction plan that includes, at a minimum, guidance and assistance from the Federal Highway Administration, U.S. Coast Guard, and U.S. Army Corps of Engineers interdisciplinary team identified in Safety Recommendation H-25-1 and H-25-2, and short and long-term strategies to reduce the probability of a potential bridge collapse from a vessel collision. Chair?
Thank you, Mr. Curtis. And just for clarification purposes, for recommendation number 14 to the Wago Corporation, the reference to the Wago terminal block model in that recommendation is number 280-681.
Yes, apologies if I misspoke.
It's okay. You had a lot to read there. I just wanted to make sure that we had that. I'll recognize Member Graham for an amendment.
One more time, I move to add a new recommendation. I think they'll put it on the screen here in a second. And this is to Hyundai Heavy Industries. Identify all active HD Hyundai Heavy Industries constructed vessels with Hyundai-MAN space B&W space 9S90ME space C9.2 engines installed, which are configured to the Germanischer-Lloyd rules and are designed to shut down on low cooling water pressure and alert the current vessel owners of this configuration and the circumstances of this accident.
Is there a second?
Second.
Great. A discussion, recognizing Member Graham.
Yeah, it's very clear that this automatically shutting down for this situation is inappropriate and endangered the Dali from recovering in this case. And in lieu of what we received from Hyundai Industries just last week, I think it's appropriate that we make operators aware of the configurations of their engines.
Member Chapman?
I support the amendment. Thank you.
Yeah, I agree. I think it's a good amendment. Thank you. Staff?
Staff concurs with this amendment.
Thank you, staff.
Thank you. Mr. McMurray?
All right, Board, this is a vote in favor of the new recommendation proposed by Member Graham. Member Graham?
Aye.
Member Chapman?
Aye.
Member Inman by proxy?
Aye.
And Chair Hamady?
Aye.
All in favor, Chair.
Great. Are there any other amendments? No. Is there a motion to adopt the recommendations as amended?
So moved.
Second.
Okay, great. Any discussion? Hearing none. Council, will you call the roll and tally the vote?
All right, Board, this is a vote in favor of adopting the recommendations as amended. Member Graham?
Aye.
Member Chapman?
Aye.
Member Inman by proxy?
Aye.
And Chair Hamady?
Aye.
All in favor.
Thank you. Are there any amendments to the report?
No.
No. I have just one clarification of staff. I just want to make sure. I believe it's just editorial, but while we're on the report, I just want to make sure. If you can turn to Roman numeral page 55. It's LV. just helping out. Okay, lines 1 and 2. After systems, will there be a period there? And are we striking with consideration of cost and other asset management principles?
We are. So that will follow the information that you saw in the findings. So that'll be correct.
Okay, I just want to make sure of that.
Yes,
okay.
Thank you for bringing that up.
Yeah, thank you so much. All right, is there a motion to adopt the final report?
So moved.
Is there a second?
Second.
All right, and council will call the roll and tally the vote.
All right, Board, if in favor of the report as presented, Member Graham?
Aye.
Member Chapman?
Aye.
Member Inman by proxy?
Aye.
And Chair Hamady?
Aye.
All in favor.
All right. Does any member wish to reserve the right to file a concurring or dissenting statement? I know that Member Inman does. And Member Graham? All right. So Member Inman and Member Graham have reserved the right to file a concurring or dissenting statement to be appended to the report. Are there any final remarks from board members before I close?
Just briefly, Chair, I want to begin by, again, expressing my deepest condolences to the families of the individuals who were lost or were harmed in this tragedy. Your loved ones should still be with us today. Please know that as a result of this investigation, we will continue to advocate for the full implementation of all the safety recommendations adopted today. Our goal is to ensure that no other family must endure the pain and the loss that you have experienced. Our thoughts will remain with each of you. And I also want to commend the NTSB team for their exceptional work on this investigation. I am just truly impressed with our colleagues' results and the multimodal collaboration. As board members, we all appreciate your commitment to safety, and we are especially grateful for your efforts during the challenging times you faced over the last month and a half. We thank you for that. Thank you, Chair.
Thank you very much. I would like to start by thanking Member Graham, Member Chapman, and Member Inman for their preparation in advance of today's meeting. As I stated at the start of the meeting, this was a complex investigation. We all too often get pushed in the early stages of an investigation, in fact, while we are still on scene, to determine the cause of an accident, or in this case, the cause of the 2 blackouts that led to the loss of power, propulsion, and steering on the Dali. Our investigations take time. Our findings in this investigation are a perfect example of why. Frankly, you want to know what happened and that it's right. Identifying that one signal wire among thousands of others in the main switchboard and determining it was disconnected because the label on it prevented the wire from being fully inserted in the terminal block was no small task. It took weeks of meticulous work and a great deal of expertise. I certainly want to thank Mr. Barnum for that. You, along with the parties to our investigation, including Hyundai Heavy Industries, did tremendous work in identifying that. I'd like to also extend our deep appreciation to all of Team NTSB, including our colleagues throughout the Office of Marine Safety, especially our investigator in charge, Marcel Muse, Captain Muse, the Office of Highway Safety, the Office of Research and Engineering, the Office of General Counsel, and the Office of the Managing Director for their work over the course of this investigation, and then in the development of an excellent report. And while not often recognized, we focus so much on investigators. I want to recognize Ms. Christopher. You did an excellent job drafting this report. These are complex issues. They're very technical. When people read it, I think they're going to understand it. You were there on scene working with everyone to make sure what you were putting together reflected what the investigators were finding, and I want to thank you for your excellent work. That was no small task, so great job. I also want to express our appreciation to our colleagues in the following offices for their vital support of our meeting, which is the Office of the Chief Information Officer, the Investigative Support Division, Support Services Division, and the Office of Safety Recommendations and Communications for its diligent work and advocacy to improve safety. When acted upon, the recommendations we've issued today will save lives. Thank you also to the following organizations for their collaboration with us on scene and their role as parties to our investigation: the Association of Maryland Pilots, the Federal Highway Administration, Grace Ocean Private Limited, the vessel's owner, Hyundai Heavy Industries, the manufacturer of the vessel, Nippon Kaiji Kyokai, the vessel's classification society, the Maritime and Port Authority of Singapore, the Maryland Transportation Authority, Synergy Marine, the vessel's operator, and the United States Coast Guard. Parties are technical experts that help us gather and develop the facts around the investigation, and as I mentioned earlier, they are not part of the analysis or development of the findings, probable cause, or safety recommendations, but they are absolutely critical to helping us obtain information we need to carry out our vital safety mission. I'd also like to thank Maersk and the Port of Newark for accommodating my visit and Mr. Barnum's visit to the Sirak, one of Dali's sister ships, just a few weeks ago. I thought that was extremely helpful. Finally, we look forward to working with all the organizations that were previously listed when we went through the recommendations to implement our recommendations. We will also continue working with the organizations we listed on implementation of our urgent safety recommendations. With that, I'd like to once again offer our sincerest sympathies to those who lost loved ones in this terrible tragedy and those who were injured. Please know that our hearts are with you as we work diligently over the next several days, weeks, months, and years to make sure our safety recommendations are implemented and to ensure that this never happens again. So another family never has to suffer the same pain that you all have suffered. We stand adjourned. All right.